Good morning, and welcome to the U.S. Consumer Product Safety Commission Artificial Intelligence and Machine Learning Test and Evaluation Forum. My name is Nevin Taylor, and I am the Chief Technologist here at CPSC, leading the agency effort related to artificial intelligence and machine learning, and how these and related technologies impact the safety of consumer products. On behalf of the Commission, I want to thank you for your participation in today's forum. Before we get started, I want to highlight that this presentation and all of the CPSC staff participation in the forum has not been reviewed or approved by and may not reflect the views of the Commission. Neither the Commission nor its staff endorse any particular AI or ML product, nor the presentations of our panelists. In today's forum, we will look broadly at the product category and not at any specific product or manufacturer. We request that questions or information be provided with this goal in mind. Additionally, this forum will be recorded and potentially made available to the public. As illustrated in the public notice for this event, the Consumer Product Safety Commission is taking a proactive approach to assess and analyze the safety implications of artificial intelligence and machine learning technologies to consumer products. We look to identify current and future capabilities to test and evaluate AI and ML. Today's forum will focus on the following 4 panels. The first will be a components panel, which will identify and test components of AI in isolation, including sensors, data, algorithms, connectivity, including communications and actuation, and computational capabilities. The second will be a products panel, which will evaluate AI-enabled consumer products as a system by monitoring and measuring and modeling their characteristics. The third panel will be on assessments, leveraging current risk assessment methodologies to identify the potential for AI ML to contribute to unreasonable risk of harm in consumer products. And finally, we will have our synopsis and Q&A panel, which will be a roundtable discussions with subject matter experts interacting with the participants regarding the previously presented panels. At this time, it is my distinct privilege to introduce to you the chairman, Commissioner Alexander Hornstein. Sir, the floor is yours.
You think after all this time, I'd remember how to unmute myself, but I want to say again, thanks to Nevin for you doing this and for the work that you've been doing with the agency on this important field. And I want to thank all the participants, and especially the panelists who are taking time to join us today on this important forum. It is my pleasure and interest as well to open the second forum on artificial intelligence and machine learning. It was something that was raised up in my confirmation hearings, and it is the future. And it's important, as the world is changing rapidly, that regulators keep up. And we are no longer in a world where products remain static throughout their life cycle. For products with AI or ML components, the product itself will change over time. These changes can be positive and allow for a universe of new products that learn and adapt to their environments, but also they raise new issues for us and for the public at large. ML and AI products complicate safety testing at times. Mechanical tests may no longer be adequate to determine if a safety hazard exists in a product that changes over time. These products, the hazard pattern may change as the product adapts, and regulators will need to adapt as well, so we can appropriately test and evaluate the products. I'm grateful to the CPSC staff for pulling this together, this distinguished group, to consider these issues. Hope that you can collectively develop approaches to address these challenges, and I look forward to hearing the results of the deliberations today. I want to thank you again for your time, and for those who are watching as well, and encourage participation in this and future events. And I thank you for the collaboration, and turn this back over to our host, Nevin Taylor, our Chief Technologist. Thanks, Nevin.
Thank you, Chairman Honsark. We really appreciate your comments and your support. On behalf of CPSC, I thank you all for your participation in today's forum and for being partners in consumer safety. My colleagues and I are looking forward to today's discussions and the ideas that will be shared for enhancing the safety of this technology. It is my privilege at this time to introduce Elam Tabasi, the Chief of Staff in the Information Technology Laboratory at the National Institute of Standards and Technology, NIST. She leads NIST trustworthy and responsible AI programs that aim to cultivate trust in the design, development, and use of AI technologies by improving measurements, science, standards, and related tools in ways that enhance economic security and improve quality of life. She has been working on various machine learning and computer vision research projects with applications in biometrics, evaluations, and standards since she has joined NIST in 1999. She is a member of the National AI Resource Research Task Force, a senior member of IEEE, and a fellow of Washington Academy of Science. Thank you for joining us today, Elam.
Thanks, Nevin, for your kind introduction and for your kind invitation to be here. It's my pleasure and honor to be here to tell you about the work that we are doing in advancing trustworthy AI. And I hope someone can share my slides, or I can try to share the screen. Thank you. So I'm going to start by saying a few words about NIST. Many of you may know the National Institute of Standards and Technology, an agency under Department of Commerce. We think ourselves as the nation's industry lab, and we have a very broad portfolio of research from building the most accurate atomic clock to modeling the behavior of wildfires, or examining why a building collapsed, as our scientists did with the building in Miami, all the way in the information technology laboratory where I am from, that we work on biometrics, cybersecurity, privacy, and of course artificial intelligence. The purpose of our laboratory is to cultivate trust in IT and metrology. And that's exactly what we are trying to do in AI, next slide, please, where you all have heard that, depends on the article you pick up or the link you click on. They're saying advanced praises of AI, that how it can raise productivity, enable more efficient use of resources, change our lives for better, cure all sorts of diseases. But there's also worries, and there are also voices that talk about the negative impact of the AI, the risks and the harms and negative impact or consequences that AI can bring in. And we all know that the truth is somewhere in between. And that's exactly what we are trying to do by understanding the capabilities and limits of the AI, artificial intelligence, understand its risks and harms that it can bring, and bring the community together to work towards developing risk management approaches, or I love this framing that I just recently learned, rights preserving approaches for advancing AI and use of AI. Next slide, please. So what we are trying to do, there is, as you all know, there is no shortage of high-level value-based statements that talk about how AI, the promises of AI and how it can change our lives, and come up with high-level statements of need for AI technologies and systems to be trustworthy, ethical, responsible. Examples of those documents are for example, the OECD AI recommendation that many countries, including the US, has signed into that. There's also many national AI documents and strategies. And in the US, we had seen several executive orders on advancing the trustworthy, responsible AI. What is in common among all of these documents is the core of advancing democratic values and developing technologies in a way that protects rights and inclusive of the whole community and demographics. But as I said, all of these documents are high level and aspirational. And the opportunity for us, the tech community, is to take these high level aspirational documents and principles and transform them into technical and socio-technical requirements and attributes that the AI practitioners at the various stages of the AI lifecycle, let them be designer, developer, deployer, tester, procurer, policymaker, any of them can use those requirements in designing or developing or testing or procuring AI systems. So what we're trying really to do is taking the principles to practice, or we are trying to come up with approaches that allow for operationalizing values stated in those high-level documents. So the first thing we need to do, which is the bottom row of this pyramid, is to understand what constitutes trust. What do we mean by trustworthy technology? What are the attributes and characteristics of a trustworthy technology? So we are trying to identify building blocks or technical or socio-technical requirements for trustworthy AI. And I will be talking about them a little bit more. Once we get those, and just for example, these encompass values and requirements such as security or privacy or safety, which is really important for consumer protection. Once we come up with that sort of taxonomy, it's really important to develop the right terminology and vocabulary. It is often the case that we use the same term meaning different things. And in the space of the artificial intelligence, this gets exacerbated because as we all know, AI is all context-based and all AI systems are socio-technical. So we really want to have a very diverse set of people and thoughts around the table across the whole AI lifecycle. So we want engineers and computer scientists and mathematicians and statisticians to help with the design and development, but also psychologists, sociologists, cognitive scientists, policymakers, lawyers around the table to think about the impact of the technology and how it's going to be used. So not only we are working with a field that's evolving and complex, but by bringing and the necessity to bring all these different diverse thoughts, the problem of using the same term meaning to different things or using different terms for referring to the same concept gets even more complex and need to address that. So for those building blocks identified in stage one, we want to bring the whole community on a shared understanding of what do we mean by bias? What do we mean by privacy? What do we mean by security? This is really important for the next step, which is the ability to assess and measure. For us coming at NIST, measurement and measuring is really our bread and butter and really near and dear to our heart. We often quote Lord Kelvin that if you cannot measure it, you cannot improve it. So if you want to improve the trustworthiness of the systems, if you want to increase the trust and confidence in the systems, we ought to be able to measure the trustworthiness of the current systems. So we need metrics and methods, we need test data, we need testing methodologies and benchmark to be able to do that. But of course, before getting into developing metrics, first have to have a good understanding of what it is to measure, and that is the step of the bringing the whole community on a shared understanding of terms and technologies. Many of you know that today is the last day of our workshop, and the last 2 days of the workshop that we had there across 8 panels. The importance of the harmonized, interoperable, understandable terminology was keep repeating and repeating. So I'm just trying to emphasize that point here. So these 3 steps: understanding the building blocks, having a shared understanding of what we are talking about, metrics, test methodologies for conformance and compliance tests. These are real important building blocks for a risk management, where they bring a common interoperable language for understanding, identifying, tracking, measuring, but most importantly, communicating about risk. As many of you know, we are in the middle of development of AI risk management framework, and I will be talking about it in a, very, very briefly about that. And the importance of governance. So the other thing that we heard is that any of these things, for advancing trustworthy and responsible AI, you got to start with governance and end with governance. And governance is actually, the way we are approaching it is process governance, having the right policy, procedures, documentations, transparency in place, but also technical governance to be able to, again, measure, identify, and track risks. And all these will provide quantitative data and evidence for sound policy considerations. Next slide, please. So I talked about bringing the community and engaging the community on coming up with the building blocks of the trustworthy AI. And what you see here is what we come up with many consultations and engagement with the community. We have divided them into the 3 categories of technical, socio-technical, and guiding principles. There are many different ways to come up with different categorizations. This categorizations is motivated by the testing needed. In the technical category, you would see attributes such as accuracy. Of course, you want your system to be accurate, the error rate to be low. But on top of that, you want it to be reliable, robust, and resilient. And what we mean by this is basically that, if I can put them all together, is that it's the system is repeatable and reproducible. It keeps its performance for the data, different data environment conditions, different than the training sets and the training data. So the performance, the accuracy, and reliability observed during the training, during the building of the model, you would get the same performance in real-time settings. And of course, we all have heard a lot about the different vulnerability of the AI systems, that they are brittle, they fail, they behave at times the way that we can't understand that, and that's because that they work on inferences rather than a truly causal relationship between input and output. So it's important to understand and be able to measure resilience of the AI system to many different perturbations and vulnerabilities. These 4 attributes that we put under the technical characteristics, they can be measured more or less in an automated way without the need for human interpretation. The second category is the category of the socio-technical, and here we have the terms such as explainability, interpretability, privacy, safety, and managing bias. So I start with the bias. First, I will say that not all biases are bad biases. Sometimes we design bias in the system. An example that I always bring up is the insurance, car insurance for the different ages, right? The younger adults pay a bit more. And that sort of bias is built into the system for very good reasons. Explainability and interpretability, we separate them into 2 different attributes, because one of them, explainability, focuses on the relationship of the input and output. And if I want to explain it in a very high level, it explains how the model works, and it's of most interest to the people that are developing the system for reasons such as debugging the systems or understanding what the model and algorithm does. Interpretability, however, is trying to bring more context and talk about the why, and it's really important for understanding why the model, why the machine learning or AI algorithm or system came to the predictions or decisions that it offers. So if, for example, a loan application is denied, what was the reason for that? Privacy and safety, both of them really important topics and extremely important. I just want to say that as we move on with any of these things, we have a focus on or looking at them through the lens of AI. So privacy, safety, bias, all of these things can be attributes and important topic for any IT systems. Within our work, we are looking at privacy of the models, right? You know how we all have heard that some of these deep learning models, some of these large models, basically memorize the training data. So it brings some certain risks to the individuals that their data had been used for training machine learning. Imagine that patients' data are being used for building a model, AI algorithm for some healthcare purposes. So there's certain privacy risk there. And I know that safety is something really important and something particularly to this group, and also for the AI researchers to understand what safety in AI means and how to measure and improve that. What is common across all of these things is that the evaluation of this requires human interpretations and somebody to decide how safe is safe, how private is private. And I will just say this, that the work that we do at NIST, we just provide guidance and technical and scientific foundations for understanding each of them and methods and metrics for measuring them. The threshold for how safe is safe, what's the risk appetite and what is the acceptable level of each of them is really application dependent, really up to the owner or the actor here. Is it the designer, developer, deployer, or policymaker to come up with that level? And that is something that we think it's one size fits all won't work, and it has to be done with a very thorough cost-benefit analysis to come up with that level of threshold. And the last category is the guiding principles of the fairness, accountability, and transparency that are extremely important, that go across the whole process, and that relates to the governance and important to keep in mind. Next slide, please. So I told you about the extensive engagement that we had done with the community to come up with these attributes. And meanwhile, I also talked to you about the high-level value-based documents. What I'm showing here is sort of a mapping or walkthrough from the taxonomy that we provide to what we see in, for example, OECD AI recommendation, executive order on advancing trustworthy responsible AI. The number is 13960, but also the EU AI Act, because a lot of the conversations that's going around them. So as you can see here, the whole high-level concepts of trustworthy responsible AI has been proposed in these other documents. We try to bring it down into closer to the practice, into requirements that could be understood with the more, technical people or policy people or lawyers or sociologists and psychologists to design, but also importantly to test the systems for these characteristics. Next slide, please. So I just want to wrap all of them up and bring it to a high level kind of selfish plug of the work that we do, that our trustworthy responsible work at NIST is really focused on cultivate trust in the design, development, use, and governance of the AI systems and technologies. And we have many different a line of efforts and research work on understanding bias, on security of AI, on explainability and interpretability, on evaluations, but all of them come together in the development of the AI risk management, a effort that many of you have been engaged, and we are grateful for your participations and the comments and inputs that you have provided in the various drafts that we have put out. The National Defense Authorization Act of fiscal year 2021 has a section called AI Act, establishment of the National AI Initiative Office within OSDP, and that office is being supported by two bodies. One of them is National AI Advisory Committee, and that's a committee of high-level experts in AI, and statute identifies something about 13 different tasks for this committee to advise the President and the National AI Initiative Office on many matters of the AI, from workforce to US leadership and competitiveness, to the state of the science in AI, particularly artificial general intelligence, and the establishment of that. Secretary of Commerce, according to statute, asks Secretary of Commerce to appoint the members, and establishing that and supporting that is also something that we are very busy doing that. And of course, standard and evaluations, that again, that's squarely in our mission and very dear and near to our heart. I will say a few words about evaluation standard. Next slide, please. So on evaluation, So on the risk management framework, just one more point that, as I said, we are in the middle of the building this. Statute gives us 1 year, January 2023, for releasing what we call a completed version 1.0. The work is not going to be finished as the technology is evolving and changing. I think the framework needs to be updated to reflect the changes of the technology. We put a initial draft out in March 17th, and this week we have a workshop discussing the draft. The structure of the framework, as it was proposed in the concept paper that we put out last year, follows the structure of the other frameworks that NIST has put out. It has a core with functions and categories and subcategories. The functions that we propose and got a good reception from the community is the functions of map, measure, manage, and govern. Again, it should start with governance and end with governance. A phrase that I heard and like very much is map, measure, manage in a sea of governance. So in the map stage, the idea is that to understand, identify, and recognize the different risks, but also, and more importantly, the context of use, because as we all know, AI without context is meaningless, and every AI systems, we keep saying, is a socio-technical system. Once the risks are identified, it has to move on to assessing, analyzing, and tracking those risks, and that's again where there is a need for measurement and metrics. And out of that can come out many different standards for performance, compliance, conformance testing. Once the context is understood, risks identified, assessed, analyzed, or tracked, then it's time for prioritizing and managing those risks. This is where the cost-benefit analysis is really important to understand the including the cost of not using AI, right? How you get with the use of AI, what type of risks it's bringing, but also all the way to understanding that sometimes the risks are too high, that the AI system should not be developed, or it needs to be decommissioned, for example, because of some sort of expiration or changes in the algorithm. You would see that these are all circular because, again, another thing that we heard is that these activities has to be continuous and evolving. If I want to wrap up everything, and what we heard is that it's critical to have common language. It's critical to do continuous map, measure, and manage. it has to be an evolving process because there is a lot of unknown, a lot keeps changing. So it's really important to adopt a growth mindset that the system changes, and then again, the importance of governance, that what's really needed to do is to establish and cultivate a culture of understanding risk and appreciation or acceptance of risk management at every stage. Next slide, please. So on AI evaluations, I said that if you can't measure it, you can't improve it. This is something that we truly believe in. But why we need this and what are the things that needs to be done is that, again, that's going to be a continuous process, that the metrics, while there is several metrics right now proposed by academia, industry, researchers all across, we don't know the efficacy. We don't know how effective those measures are. And if the measures, for example, proposed in one sector, I don't know, healthcare, can also be used for another sector like financial sectors. So the activity of continuously devising and revising metrics, assessing their effectiveness and their appropriateness for the task. We have to develop representative test data. So there's a lot of talk about the training data to be representative and unbiased, but all of that becomes even more important on the test data. I always say if test data is too easy, everybody wins. If it's too difficult, everybody loses or fails. So it's really that Goldilocks problem that we really want to have, and the right test data, but also representative of all the different failure modes. Evaluations and measurement of the AI is not just looking at the aggregate, because every failure mode is important that has to be studied. And again, I think that's very important to the context of your meeting today and the safety, that you just don't want to know on aggregate how safe a product is. You want to know every single instances of failure and every single instances or possibility of an unsafe outcome. The importance of assessing real-world performance. So while a lot of discussions and energy are into evaluate models in the laboratory setting and the research setting, but what happens when you get them and bring and deploy it in a real-world setting, when it starts interacting with data and environment and conditions that are probably different from the one that it has been trained on. And last but not least, interoperable test and test results. So if we can have many different testing, and I hope that we will have an ecosystem of test and benchmarks and test beds. If there isn't a way of interpreting the test and test result in the same way, then we can really have a meaningful comparison across these evaluations. So some product or systems that gets a very high ranking in one of the tests may fail in another test because they're using different methodologies or test data or conditions. So that's sort of a call for action for standards and communities to come up and be able to develop interoperable test and methodologies and reporting of the performances. Next slide, please. So standard is a really important activity. Standards provide that interoperable language for communications of many different, technical and non-technical topics, and they also provide the guardrail, the safe space for innovation to happen. They provide a level field for competition to happen. So standard is our middle name, but I always say that we are not standard development organizations, and there are many really good policy in US, including the OMBA 119 circular, that standard development in US is private sector led, is industry led, and there are roles for federal government to support private sector in developing and advancing development of the standard. standard. But one of the hats that I wear is the USG AI standard coordinator, with the goal of bringing federal efforts together and bring more focus on many different ongoing discussions across many different agencies, and strengthen the tie with the private sector in advancing AI standards. Next slide, please. And this is my last slide. What I want to try to say here is that I talked about a lot of things, but one thing that I want to really emphasize on is that the spectrum of our work goes from fundamental research on understanding limits and capabilities of AI, what constitutes trust and trustworthiness, how to build AI models and systems that exhibits those trustworthy characteristics, bringing them to applied research, how to build systems and test systems in different verticals, in different application domain. So get those sort of abstract concepts into the real applied research. And then work with the standard community and build standards and guides and practice guides to help advancing those trustworthy concepts and characteristics, and actually put them in use in very practical terms, which brings us to adoption. So if you're talking at a very high level and abstract way about biases in AI, which we had a report out about 2 weeks ago on March 14 or 15, bring those all the way into adopting systems, products, services, where we can understand the bias and measure the bias. With that, I think I'll thank everybody for your time. Really appreciate the opportunity. So the last slide has some information about how to contact us. Thank you so very much. Nevan, back to you.
Thank you, Ellen, for joining us today. We are grateful for your vision and look forward to your continued leadership on these important efforts. I'll now hand it over to Einstein Miller, who will introduce our esteemed panelists to share their views and offer their perspective on AI and ML components. Einstein?
Good morning. My name is Einstein Miller, and I'm an electrical engineer in my 11th year here at CPSC. I'll be moderating the components panel. We have 4 speakers who will present on data, algorithms, connectivity, and computation. First, we start off with Mark Wolf, advisor, industry consultant from SAS. And we'll move in with the connectivity, IoT, and sensors with Katharina Megas and Dr. Mike Fagan from the National Institute of Standards and Technology, NIST. And then we'll end our panel with a discussion on computation and capabilities with Serge Leontev, Master Principal Solutions Engineer at Oracle. Our first speaker today is Dr. Mark Wolf, with 30 years of experience in the health and life science industries as a scientist and analyst working in the US and Europe. He is an advisory industry consultant and chief health analytics strategist for SAS Institute's Global IoT division, and holds an academic appointment as a visiting fellow at the University of Miami Institute for Data Science and Computing. He is recognized as an accomplished practitioner and thought leader in the development and application of advanced and predictive analytics. His current focus is on the application of machine learning approaches to streaming sensor telemetry and unstructured data in support of improving health outcomes, patient safety, and the design of intelligent decision support systems. Thanks for joining us today, Dr. Wolf.
Thank you so much, and thank you to the Commission, to Nevan and Einstein. Thank you to you. It is a genuine pleasure to have a little bit of time with you today to share several of projects that I've been working on related to machine learning, AI, and more importantly, the broader concept of safety. And what I hope to do today is share with you some of that work and possibly both inspire and motivate you to think about how to approach some of these problems, perhaps in ways you may not have considered. And some of the work is also based on projects that I've done with the US Food and Drug Administration, where we have been working on not only understanding, but trying to predict adverse events in the therapeutic world. And now, how can we translate some of that work into the consumer product world, where we can take advantage of our learnings and our techniques and apply them in this particular case. So today I want to start my first presentation around this concept of how to apply machine learning to data that is available from the web, social media data, internet data, and more importantly, how do we develop ML and AI techniques to actually validate those data? How, to be honest, how do we build a lie detector for the internet so we can use those massive amounts of information to support decision-making around product safety? Next slide, please. So to that end, let's begin with a very brief look at data itself. I don't think I need to spend much time to tell you that the growth in data globally is just incredible. The numbers are stunning. But what I want to highlight here is that the vast majority of that increase in information that is available for analysis, and that's an important way to construct how to understand data, is in unstructured data. And by unstructured data, we mean information that is not available in, let's say, a relational database with high data quality and high integrity that we can then use for study. So how do we address the challenge of understanding unstructured data? But more importantly, how do we also understand how to validate and have trust in unstructured data? Next slide, please. So if we're looking at unstructured data, what essentially are we talking about? Well, we're talking about documents, text files. We're talking about logs, server logs, as you can hear, a variety of telemetry from a variety of sensors, whether that's a wearable, whether that's a camera monitoring some area. That brings us to the idea of images, both static and video. You well know that the internet is just overflowing with these types of information. Audio files, sometimes we don't think about that. Certainly we think about emails. And finally, a topic that I want to address in some detail, social media data. Next slide, please. So I want to spend just a minute to help us understand how we approach analytics. Now, I work for a company whose core value proposition is the development of analytic software. How do we take data? How do we analyze it? And how do we use that analysis for decision making and decision support? Very briefly, the traditional sort of analytic life cycle, as it's called, is we move from some source of data, we store it somewhere, we process it, we organize it, we then use those data for some form of analysis. That analysis then drives the support of decision-making, alerting, and so on. Classic standard flow of data, analysis, decision-making. What has changed recently is the ubiquitous availability of streaming data. That is time series data, highly dimensional, high frequency data that is being collected by a variety of data generating sources. Often we refer to them as sensors, but they could be cameras, they could be microphones, so on and so forth. So what changes now that we have the streaming data? Next slide, please. Well, what changes is our ability now to, in essence, bypass this traditional analytic life cycle and move to looking at the streaming data, data in motion in real time. So we can now apply analytics and machine learning and AI techniques, not to data that exists in some data warehouse, but rather apply analysis and apply learning to data as it's moving. And that's very important. Next slide, please. What that means is now that we can develop methods not only of scoring moving data, that is, how do I understand a prediction or some analysis of data while in motion to support my decision making, but how then do I use that to also build new models, new understandings of those data? This fundamentally develops what are called learning or adaptive systems, very much mimicking and recapitulating very much the way the human nervous system works. Next slide, please. So what that means is now we can take text and images and in real time process those, next slide please, in a way such that text and images drive not only an improved understanding of something in the world in real time, but drive extensions of adaptive learning systems, even more so recapitulating the human nervous system. That is, we not only work and make decisions, AI versus real intelligence in humans, we not only work in terms of making decisions based on our memory, but we make decisions as we perceive the world in real time. So this form of data, these forms of streaming analysis now can be transformative in our understanding how to monitor and how to react specifically here to safety related issues. Next slide, please. So we're going to move a little quickly through this because I don't want to be too pedantic around what things are or not. So we're going to focus on text analytics and natural language processing. Very briefly, text analytics is the application of mathematical, purely mathematical approaches to understanding unstructured data, text. Natural language processing is a component of text analytics whereby we understand the language. We use dictionaries, taxonomies, and ontologies to essentially disambiguate, to understand not just the mathematical constructs of a document or a corpus of documents, but rather now to understand the language. What are the words? What do they mean? So this is an important distinction because both components are extremely valuable in understanding unstructured data. Next slide, please. So how does this then apply to unstructured data, more importantly, on the internet, and even more precisely in social media? And this is the area where we focused on. So social media obviously is full of unstructured data, images, texts, and sounds. Let's focus on text. Let's focus on what people write, what is written in documents in various platforms around the internet. How can we use those data to enhance and inform decision-making based on other more traditional forms of information? Next slide, please. So to that end, one of the challenges we have, particularly as related to health and safety, is many people, many platforms have data that what is considered unsolicited, self-reported health outcomes data. I'm on a forum, I'm discussing my health. I could literally type in this forum, I experienced this event with this product. Nobody asked me to talk about that. Nobody encouraged me. I reported that, self-reported that, and more so, there's no context to it. It is simply an individual on a forum posting some information. How do we use that information? Next slide, please. Well, the challenge is, how do we believe it? It is useless if we have no confidence in the data. So one of the things that I worked on, and the team here at SAS worked on, is how do we create ML and AI methods to process that information such that we trust that information in order to support decision making, whether, for example, lots of people posting about a product that has injured them, we believe that, as opposed to saying, no, this is not true data, this is some sort of manipulation. Next slide, please. So there are many instances where the vast majority of safety data, whether related to therapeutics or other products, does not exist in formal databases. From the perspective of adverse events from medicinal products or medical devices, most of that information does not exist in databases that we understand. So we need to think about and we need to look to new forms of data, and social media actually is a very plausible place for new data. Next slide, please. How plausible? Well, not too long ago, the FDA actually had a solicitation asking the broader industry, can the industry provide ideas and opportunities whereby the FDA can use social media for, as you see here, early detection of safety events. So there's a precedent here set by the US FDA, and I'll describe the work I did related to that project and how we can translate that work to consumer products and to both understand and potentially predict safety events in consumer products. Next slide, please. So within the FDA, one of the interesting sort of changes that occurred over the years is that they moved not simply from understanding safety and efficacy of the products they regulate, but they moved also to try and understand public sentiment, public opinion, or what they call patient preference. So the question was, how do we collect patient preference? Of course, we can do surveys. Of course, we can be proactive. But how can we passively collect that information from the web? Next slide, please. What we found was that we can look to what are called patient-reported outcomes. Basically, this means, let's say somebody on Amazon writes a review, and it's an outcome of their experience with a product. Fundamental question, can we trust that? More importantly, what information can we extract from that review that is useful, that we trust, and we can use in decision making? So if somebody talks about this product hurt me, how did it hurt them? Did it really hurt them? And can we believe that? So I'm taking the work we did with the FDA and moving it now into the consumer world. Next slide. We're going to move quickly through this. So Google Trends. Often people say, well, just type in a word, injured by this product, and see what happens. No, Google Trends is not a reliable source of information based on certain key terms, unstructured data related to safety issues. We did a lot of work in this space and we found it, frankly, quite unreliable. Next slide. And I know I'm going through this quickly, but I think you're getting the sense here. Twitter. Next, well, what can you find out about Twitter? People talking about safety or their experiences with products and safety. No, Twitter was proven not to be a useful and verifiable source. Often, Twitter represents an overreaction and, in a sense, a platform for amplifying a voice or amplifying a comment that may not even be real. And tremendous amount of literature exists in the space to actually show and document how Twitter often is at odds with quote unquote reality. Next slide, please. So what do we do? Well, in this particular project, what we did was we looked to multiple websites where people freely, publicly, and openly posted information about their health experience with medical devices. We looked at a variety of websites and collected immense amount of information, basically comments. Those comments included a username, a date, potentially some other metadata, and the actual comment they made about their health status relative to a health product. Next slide, please. Using those data, we were able to collect individual comments and, using both text mining and text analytics, extract key information. What is the product of interest? What was said about the product of interest? So this is a process, a standard process of extracting knowledge and information from unstructured data. Next slide, please. So we identified what product is being discussed. We identified what elements, what issues related to the products are being discussed. Next slide, please. And further, we were even able to understand sentiment formally. That is, overall, we understood the comment was about a particular product. It was about a particular event. And could we also understand, using ML and AI techniques, what was the sentiment? Was the comment positive, negative, or neutral? These are very well-established techniques. The challenge is we're addressing those techniques to data from social media, and we also want to understand, can we trust those data? Next slide, please. So to that end, how do we then effectively reduce the complexity of that process so that we can do it in real time, as I mentioned earlier? So we focused on the mathematics because the linguistic natural language processing capabilities, although very powerful, are also very computationally intensive. So how can we create near real-time mathematical analysis to reduce the complexity of scoring millions, tens of millions, hundreds of millions of comments? How can we obviously increase the speed so that we can have streaming analysis? And how can we create a situation where we identify emerging trends? So we're not looking for something that we know, this product hurts in this way, but rather we can identify emerging trends that say, we've never seen this before, but the frequency of that event is increasing. Next slide, please. So to that end, we developed a system whereby we use rules, that which we know, that which we well understand. We created mathematical anomaly detection, mathematically, statistically, and from an ML/AI perspective, how are the events expected over realized occurring. We built a variety of models using pattern recognition and deep learning to understand patterns and trends of how individuals post. What are they saying? How are they saying it in terms of the mathematical structure and patterns? Believe it or not, it is really, really difficult to lie when you write. It's much easier to lie when you talk than it is when you write. And to that extent, we can use ML and AI to actually score that writing and give it a veracity score. And then we use network analytics. This is critical. How do you link any one piece of information to a broader set of information, thereby having confirmatory analysis based on rules, anomaly, predictive models, patterns, and now networks, the connectivity of those data. This proved to be a very powerful approach to basically a lie detector for the internet. Next slide, please. So with that, we then did other studies to validate those approaches, and even studies in other languages. This is really, really important. Mathematical text analytics is effectively independent of natural language processing's dependency on a language and a translation. We can use mathematical analysis across languages, and we can use it across massive, massive amounts of data. And in this case, we're looking at relationships. How do people feel? What are their thoughts about pain medicine and particular diseases? And what are they saying? Positive, negative, what side effects are they experiencing? How can we understand behavior? Not just an event, did it, did not happen, but broader behavior. Why aren't people taking their medicines? Why are people taking their medicines? And how do we apply that now to the broader area of consumer products? So there's a lot of, you can expand this across many different applications. Next slide, please. And as we get to the end, we then, here's the example of the project we did with the FDA, where we did a formal study of social media to understand what patients were saying about specific medicinal products, about medical devices, and their experience. Was it positive, negative? Did they experience side effects? Did they experience benefit? Here's a formal study where we use not only social media data, but we validated that data with our veracity and lie detector, and then we used that useful information to support decision-making at the regulatory level to better understand safety. And so this worked quite well. All right, next slide, please. To that end, we expanded that work into scaling, bigger sets of data, more information, and more importantly, adding the temporal component. Can we now detect changes and make predictions moving through time? Next slide, please. That work also proved to be very useful because we were able not only to identify, and you can see here, data in motion being scored, and the red clusters are alerts and basically areas of interest that say when these terms are present together at a certain frequency and at a certain point in time, they signal a potential issue, a potential safety issue. Next slide, please. And as we moved further, we took that mathematical approach and developed even higher level analysis for what's called signal detection. That is, what is the signal present in the data to indicate useful data, which we believe is truthful, versus not useful data. So we developed many mathematical methods. Again, the focus here was to use ML and AI on the math of unstructured data because of computational and scale issues versus applying natural language processing, which may be more challenging from just the logistics of that work. Next slide, please. And as we get to the last couple slides, what we see now is the ability to introduce, for example, bias adjustment. We've heard that term before. Imagine if a poster has some sort of, let's say they have an issue and they want to be heard and they want to bias the signal in the social media world. So let's say they have many different usernames, but they keep posting the same net message. Using ML and AI, we are actually able to model the mathematical patterns of the postings, associate them with multiple usernames, and make the mathematical inference that that's the same person or group posting essentially the same message, and therefore it is not useful. That is, we identified a bias in a message based on ML&I approaches of modeling how people post. So this idea of veracity, the idea of understanding bias, can now be done mathematically to social media. And then in the final couple of slides, which you see here, next slide, please, is a kind of, how did we do that? We used social media. We used known data that we have. We used documents. We used connectivity between different data. We used data from wearables, from phones, whatever the source. We bring that together. We apply machine learning, pattern recognition, rules. We extract information using, where appropriate, natural language processing and text analytics. We address disproportionality. We confirm. That results effectively in a subset of data that we have high trust in. And in the last slide, it kind of represents a funnel, right? We start with social media, we put it through these mathematical approaches, things like frequency of posting, word count, cross posting, and author fingerprinting and bias detection. And those 4 elements there essentially identify the components of that veracity scoring method that I described. And at the end of that, when I look at social media and I filter the data, what is left for me are data useful in decision-making around whether individuals were speaking of real or not real safety events, and how can I use that information for decision support. And with that, I believe we may be spot on time for the first presentation. So thank you so much. I hope that I've maybe piqued your interest in how we can use new forms of data, new, not that social media is new, but rather that accessing those data for critical safety decision making is new, and we can do it in a way that we trust the data and we trust our decision making. So the last slide, please, I think is the last one. Right. Actually, can we go back one slide? Okay, so I'm missing the title slide for the second presentation. No worries. Let's go back. So the second presentation, they're back to back. The second presentation is around opportunities and challenges of AI in consumer products. Yeah, let's stay on this slide. So what does that mean? I want to take it to the next level. Now that I've talked to you a little bit about the data and talked to you about how we can extract useful information from challenging data, how then do we now look at the algorithm itself? How do we look at the AI and trust that the AI that made the decision on the data is also trustworthy? And I want to challenge you a little bit in terms of new approaches to basically validating or verifying the integrity and the robustness and viability of an algorithm that is a component of a product. So the product, maybe it pinches you if you use it incorrectly and it causes a cut. That's a safety issue. What about the algorithm? How does the algorithm interact with the product now, as we've discussed over and over? What is the role of that algorithm and how do we test its safety? So I use the term in silico we trust. So how do we trust the algorithm, the computer? Well, many of you may be familiar with the scene in 2001 Space Odyssey, where HAL, the computer, the artificial intelligence that is supporting the astronauts in running the spaceship and going from Earth to Jupiter, at one point in the trip, the computer alerts the crew and tells them that a communication module will fail. Not only does it tell them that the AE-35 communications unit will fail, but it will fail 100% within 72 hours. I think many of you know that in today's world, this idea of predictive asset maintenance, using AI with hardware to have the hardware basically tell you through the AI algorithm what is wrong with it and when it will fail, so that you can replace that before it fails. This is in the industrial world, asset maintenance, predictive asset maintenance is a huge area where machines basically are predicting their failure. Well, 1969 in the movie, this was already envisioned. The challenge was here. Hal was lying. Well, I don't know if Hal knew he was lying, but Hal basically was not telling the truth. So the algorithm was predicting an event that indeed was not true, would not happen. So even in 1969, we were thinking about algorithms making predictions about products, about components. And even in 1969, we were essentially concerned, what if that algorithm was not truthful? What if that algorithm was false? What if the confidence we have in that algorithm is wrong? When challenged, Hal simply said, no, I'm not wrong. Humans are wrong. So let's explore that area. Next slide, please. So artificial intelligence and machine learning. How do we now think about that from a smart consumer product, right? Smart or intelligent products are basically defined where some level of decision making based on data from the product is embedded in the product. I think all of you are well familiar with that. I'm not going to spend a lot of time on that, but this is an important distinction, right? We can have a product that simply performs a task. Now we have a product that performs a task and has some level of autonomy and has some level of compute. It is collecting information, processing that information, and either supporting decision-making on board, what's referred to as an edge device. The product itself is analyzing data, computing data, and then possibly affecting some form of response, or it's giving us information to support decision-making. Next slide, please. To that end, what makes a product smart then, right? How do we make a smart donut? Here, I'm sure many of you've seen that Simpsons episode. The idea is we need to look at where do we evaluate the algorithm for its potential safety? Where do we look to Hal at the space station? Where would the astronauts look to figure out whether Hal was lying or not? So is it about the gathering of data? Well, of course, the garbage in, garbage out thing, we all understand that. Is it about the actual report or the action related to the data? I would argue it's the analysis of the data that may be the primary or the first place we look for the integrity, the robustness of an algorithm. That is, what are the calculations? How are they being made? And are they consistent? And then look to the data source and to the output in order to confirm the analysis. So I would argue we may want to start at the analysis point. Next slide, please. So to that end, if artificial intelligence is all of that together, data input, processing, understanding, modeling, using that modeling to then make decisions, and you can see here all the elements, all the incredible elements that go into it. Where do we start? Because all of these elements are related to the analysis. All of these elements are trying to come together to simulate what? To simulate the way a human works in terms of understanding a problem and acting on a problem, which is making a decision. So the algorithm's safety, if you will, is about the quality of decision making for that algorithm. Next slide, please. So to that end, if we think of it in those terms, what does that then mean? Does that mean that we go bit by bit, step by step, and we look at every equation, every function, and we basically look to see whether we get the correct answer? Well, we can do that, and we can get the correct answer every time we examine that. But when it goes into the product and it goes into the real world and it's being used, there are many opportunities for that algorithm to make the wrong decision, quote unquote, whether it's through things as emergent behavior or stochastic behavior. Just because the math adds up on paper does not mean the math will add up in the real world. Next slide, please. So those opportunities really are about taking the math, taking the product, and understanding how that product behaves autonomously in the real world. So we have these puppies, right? These little autonomous dogs. Wouldn't it be interesting, in spite of all of the programming, if that puppy actually bit somebody? How could we predict that, right? How could we literally predict that the algorithm which has no concept of biting, actually results in a situation when if a finger goes into the mouth of the puppy, it actually gets bit. And as these algorithms and the decision making becomes frankly ubiquitous in products, from toys to very important products we use in our homes and in our lives every day, we need to be able to understand not just the math on paper, but the emergent or the stochastic behavior of that algorithm in the real world. Next slide, please. And many of you understand that that algorithm potentially is the core of the safety issue, right? So how do we better understand the risk to benefit of the equation inside the product relative to safety? Next slide, please. Well, you're very familiar with this example here on the left, right? Famous study, everybody uses it. They trained a machine to identify a wolf and a dog, and it did a brilliant job. Turns out what it identified, when it identified a wolf with a high degree of accuracy, was every time there was snow present. So we know that story. We have to be aware that the math can work, but that the math, even though it's working, contextually can be highly erroneous and problematic. I don't know how many of you saw this tweet from not too long ago. I thought it was fantastic. Somebody posted a study that said bad reviews for candles on Amazon often included the term, "they don't have any scent." Okay? Remember what I said about text analytics earlier. Imagine reading a review, "Oh, I don't like this candle because it doesn't smell." Well, what's absolutely incredible is if you plot the frequency of reviews where candles don't have smell, it's an almost excellent correlation between the incidence of COVID. So the question is, just like on the picture on the left, are the Yankee candles just not smelling well and people are complaining? Or is the fact that the incidence of COVID related to lack of smell in those that are affected is now essentially providing a surrogate set of data in the reviews on Amazon for candles? And so we can actually say, yeah, COVID probably is having an effect on people's smell, because everybody who bought a candle and they posted a review on Amazon said they can't smell anything. We really have to be careful. And that old statistical adage, correlation is not causation. So again, that's at the fundamental algorithm level. Okay, next slide, please. I want to talk a little bit about, I want to talk a little bit about CAPTCHA, okay? Now, why am I going to talk about CAPTCHA here? So what is CAPTCHA? I don't know how many of you know, but CAPTCHA is it's an acronym, the completely automated public Turing test to tell computers apart from humans. What CAPTCHA is designed to do is to basically offer you an image with some text, as you well know, and if you're a human, you'll be able to understand what those words are. If you're a machine, you won't. But what's important about CAPTCHA, and why I'm bringing it up here, is that CAPTCHA actually helps us understand how the human brain processes information. And my argument to you today here in this presentation is, can we use that approach to understanding algorithms, AI, in order to better qualify whether that AI is a good AI, it's reliable, it produces information that is valuable, and that information can be used for decision-making, trustworthy decision-making, versus an AI that is quote unquote unsafe. And so the idea that CAPTCHA and the way CAPTCHA works can be applied to how we understand and evaluate the safety of algorithms, I think is plausible here. Next slide, please. So to that end, let's look at this concept here. Cost to benefit, right? All right. How much do we invest in understanding the value of a product or the safety of a product vis-a-vis its benefit or cost? Next slide. Well, it's not a simple ratio. And here's where the math, the algorithms, and the AI come in. It's really a complex nonlinear relationship. Next slide, please. Next slide. We need to understand benefit and risk benefit to cost from a low risk perspective, next slide, to a high risk perspective. Next slide. And more importantly, we need to do it over time. Now, remember the comment I made about understanding data over time, doing it as it's streaming, understanding the cost to benefit between high and low risk and the value or the safety of a product through time means that the algorithm potentially will provide different responses. We can't just look at an algorithm at a point in time as a static entity within a product. We need to think about the safety of that algorithm, if you allow me to use those terms, as it's moves through basically that product while it's in the consumer space over time. That is a complexity. The temporal component is a profound complexity. How do we address that? And next slide, please. So how do we address that? Okay, we need to address that from a perspective of better and safer algorithms. Next slide, please. What that means is we need to think about something quite, believe it or not, historical. Ross Ashby, a father of cybernetics, basically said that the level of intelligence or the quality of an algorithm, this is important, is a function of both the amount of data and the ability to process it. Okay, so one aspect of understanding the safety of an algorithm is as much data as possible and as much processing as possible. But that's not really practical, right? Next slide, please. So the other thing we have to understand from what Ross Ashby did was this very interesting law of requisite variety. This is not academic. This is really, really important. And let me tell you why. Ross Ashby said the following: for a system to exist in homeostasis, what does that mean? An algorithm is stable and it's producing reliable information or reliable decision making. For that system to be stable, the number of states of a control mechanism that it's capable of attaining must be greater or equal to than those states that are being controlled. Let me explain what that means. If I have a product that has a light sensor, a simple light sensor, and it turns current on when the light is off, and it turns current off when the light is on, what that means is that system has one state and needs a minimum of one control state. Now, if we understand that and we're reviewing the value of that system and that equation that's running that system, this is an indicator of how safe, quote unquote, that system will be. If we have a product that has multiple states of control, light, temperature, humidity, voltages, on and on and on, at minimum, we have to understand that that product, vis-a-vis that algorithm, has to have an equal or greater number of control states. So the first question we should ask ourselves when looking at an algorithm based on AI applications for consumer products is, what does that algorithm interact with and control? And how many states of control do we have associated with it? If it's less than, then it's not a good algorithm. We need an equal or more number of control states for the number of states in that mechanism. I hope that makes sense. I know that seemed academic, but it really isn't. What we need to do is look at an algorithm, see all that it controls, and make sure that we have an equal or greater number of elements to support that control. Next slide, please. And I'll move pretty quickly now. So one of the challenges of AI in terms of higher level understanding, not knowing, understanding, is that it's simple to make an AI system that is invariant. So a system that responds similarly to different views, right? So we have an algorithm, it can have different faces or different documents, but it is trained to say which ones are or are not the same. That's very easy. It's also easy to create an AI system that's selective. We're looking at a bunch of information, a bunch of events, but identify the unique one, okay? So invariance, I always identify the thing that I'm interested in. Selectivity, I always understand the thing that doesn't fit. All important elements of AI. The challenge is, how do you bring those two together? Humans can do that together. We can both look at something and say it's the same, and we can look at something and say it's different. That's how CAPTCHA works. So the question for consumer products, AI, and embedded AI in products is, how can that AI algorithm respond to its environment, both being invariant and selective. Because what that means is that that AI now is more robust and is moving between knowing, I know this is or isn't, and I can make a decision, but it's moving towards understanding. So next slide, please. And understanding is when you look at an image like that, the AI algorithm doesn't know any of this, but it will understand what those words and what those figures are and make the correct decision. I hope this makes sense. It's not about knowing. We're moving to the next level, whether AI can understand. Next slide, please. And as we finish up here, understanding is a component of things like common sense and imagination. I know this may sound crazy, but it isn't. Think about it. How do we introduce decision-making that is independent of specialized knowledge? How do you have an algorithm that can be inside of this robotic dog and know or understand that if a finger goes in the mouth of that dog, it shouldn't clamp down, but it was never taught to do that, right? I know this sounds crazy, but honestly, it isn't. The future is about algorithms that essentially support decision-making without any training. And imagination, more formally, is forming an answer or an image or a concept without actually sensing it. Okay, so for algorithms to understand, they will need to formulate outputs without training. How do we do that? Next slide, please. And there is a method. There genuinely is a method, because we're moving from knowledge to understanding. And understanding will make algorithms safer, because it will help them react to things that humans could not have predicted in the code. Next slide, please. And what that means is that we need to think of how humans do this. When a baby is born, there's so much that it has not learned, obviously. Yet they are pre-programmed to understand key things in the world. What does that mean? Structurally, it is not the math. It is the actual hardware where the math runs. Next slide, please. And we just have one more slide, I believe. What that means is that products in the future will have to be designed not just to execute a mathematical equation, they will actually have to be designed from the hardware perspective, where the actual hardware structure that executes the AI model is configured in such a way that it improves the AI. My point is, AI as an algorithm will have to work in concert with hardware and architecture, because that is the way human beings make decisions. And we will move towards products that have more human-like decision capabilities. Next slide, please. I think that's the end. Right. So it's not just computational power and memory, as Ashby said. It's also going to require the fundamental hardware. So from a safety perspective, we will look at the math, and we will look at the actual physical product that executes the math. So with that, that should be my last slide. Thank you. I know that was a lot, but I hope it stimulated your some ideas about the future of AI, and that the future of AI and safety is not just math. It's math and where that math is executed and how that execution environment is actually built. So if you understand that, thank you, then you're human. Thank you so much.
Thank you, Mark. Next up, we have Katerina Megas, who leads the NIST Cybersecurity for the Internet of Things IoT program at the U.S. National Institute of Standards and Technology. NIST focuses on advancing and accelerating the development and application of research standards, guidelines, and technologies necessary to improve the security and privacy of ecosystem of connected devices. Before joining NIST, Kat worked in the private sector and led the development and execution of IT strategies. Kat holds an MS in Information Systems from Virginia Tech. Along with Kat, Dr. Michael Fagan will be presenting. Michael is a computer scientist and technical lead of the Cybersecurity for IoT program, which aims to develop guidance towards improving the cybersecurity of IoT devices and systems. The program works within NIST and Technology's Information Technology Laboratory, ITL. Michael leads work exploring IoT cybersecurity in specific sectors or use cases, such as enterprise systems, Federal Government, Consumer Home Networks. Michael holds a PhD in Computer Science and Engineering. Thank you both for joining us today.
Thank you. We appreciate the time to discuss the connection between IoT, machine learning, artificial intelligence, and some of our work in cybersecurity that we've done here at NIST. Again, I'm Michael Fagan. I work with the Cybersecurity for IoT program along with Kat Megas. We've done all of our work really focuses very squarely on cybersecurity for IoT, considerations and guidance for different stakeholders in that area. But there, of course, is a connection, especially around consumer products, between artificial intelligence, as Mark just highlighted in his presentations, in how some, especially around decision making in IoT can happen. So I'm going to discuss some of the more cyber issues that might play into reliability of a system, and generally what we call, there are other. We'll get to it. So next slide, please. Getting ahead of myself. So yeah, this was the slide I really wanted to talk to, that I was just kind of describing a little bit more. When it comes to an IoT system, an IoT device, the way we describe it, can collect data and act on data and actuate in the physical world. That's a big what differentiates it in a large way from a traditional laptop computer, say, which interacts with the real world, right? I'm looking at a light right now, a screen, a camera's capturing my image. But these sensors and these actuators are kind of general purpose, right? Like I can use my screen to word process. I can use it for this purpose right now. The camera can be used for video conferencing, but there are other uses for it as well, recording, say a podcast, something like that. Whereas an IoT device, generally those sensors and actuators are much more tightly coupled to a specific use case, or a set of use cases, or a specific sub-use case, say. And so it'll collect a more specific set of data than my laptop would, and also be reporting it more likely to a specific place where it's then very possible AI is acting on that data. That, going back to Mark's presentation, the gathering of data is partly an AI role, or an IoT role when you think about these big distributed systems. Within, either on the edge or in the cloud or somewhere in between, there could be AI decisions being made based on that data that was collected by IoT. But then those decisions will flow back down through the system. And IoT introduces another challenge when you're thinking about risk and protecting systems and how they function, in that, my laptop and all of us here, where there are 92 of us on the call, right? That's in the broader internet, a set number of disseminations of my image. An IoT system could be collecting data from thousands, millions of devices and distributing it to another 1,000 of devices and to react to real-time data in, say, a smart cities scenario. The consumer home environment, maybe it's not so distributed, but actions that your device takes in, where these algorithms are learning from the cumulative data that's collected out of the product set, that obviously could have impacts on your home. So that actuation part is also there for where the safety comes into play, perhaps, and depending on the particular actuator. Some actuators are innocuous, perhaps, if it's a light bulb in a otherwise well-lit room, hard to distinguish specific safety concerns around that, right? But it could be an IoT oven or fireplace or something that has a heating element that could cause some sort of issue that would definitely bring in the safety domain. Next slide, please. So I've highlighted this next topic. Next slide, please. I'm not seeing the update. Oh, there we go. So I've highlighted this next slide a little bit, kind of how we, our team and others. Oh, I'm sorry, the previous slide. It hadn't updated for me. Yeah. So I've kind of highlighted at the very top, what is IoT relative to, in our case, we were generally considering traditional computing devices, conventional computing devices, we might call IT equipment compared to IoT equipment. And so that will, in how we describe it and how it's, that same description has been picked up in the Cybersecurity Improvement Act of 2020, it'll be a piece of equipment, a device or a system that has at least one transducer to interact with the physical world, a sensor and actuator, maybe both, and at least one network interface. So it interfaces those physical elements with the digital world as well. And that's really the difference of IoT, right? And the tight coupling of that sensing and actuating capability to the use case that the particular IoT product is designed for. Next slide, please. Now, as I highlighted, a lot of our work deals with, or all of our work really in the Cybersecurity for IoT program deals with security, specifically cybersecurity. So the confidentiality, integrity assurances of the data and devices from that digital level. But that, of course, ties into, as a broader system, and IoT certainly almost always is going to be included in some sort of broader non-digital system, aspects of course, safety, but also privacy, resilience, and reliability that all build in this, like, our trustworthiness of any given system or device. So consumer product sitting on the desk, sitting on a table in my home, you know, it's good to hear that it's got strong cybersecurity, but if the thing doesn't work because that cybersecurity is too robust for the use case and gets in my way a lot, I'm not going to like that device. I might not trust its operation. At least I won't trust it to operate when I need it to, and I might not use it much. You know, flip side, right? If I notice that this device seems to operate strangely, even though it's very secure, right? I have a good password on it and all, but it does things when I don't tell it to. That might create, you know, it's like maybe a safety or a privacy issue for me. Again, an extended reliability issue for me as the user of this whole system, and all that. You know, it's distinct but related, right? Because similarly, if I notice that the security is weak, I might not trust it, and I might not trust the safety implications or the safety assurances I have related to this device. So, you know, trustworthiness also changes over time and can be impacted by, you know, what kind of data is being consumed by that system as well. And like I was just highlighting, right, there may be trade-offs in some cases around achieving certain trustworthiness goals, the 5 that we've highlighted here, for example. Next slide, please. And that balancing of factors is really going to change across different sectors and especially different use cases. So in some areas, safety will be a top priority, and reliability, if it's a safety critical system, may be a top priority relative to, you know, system privacy in a more traditional sense, or system confidentiality. What I mean by that is, I mean, not to discount, right? We always care about the cybersecurity of a system. We know data breaches and leaks are a real issue and a problem for individuals' privacies when certain data is released, of course. But you know, break glass in case of emergency situations will come up, maybe in a medical situation where you know, having to log in the middle of a hospital to be able to administer certain life-saving procedures. The protocols around the risks of misuse of that system may be outside of cybersecurity, maybe part of the physical security. You know, there are additional, you know, making sure it's a doctor that's actually trying to do what they're doing. You know, the people in the room are part of that. You know, we could speculate in specific use cases of how that might work out, but these are the challenges of, especially when safety starts to come into play, understanding the balance and the fact that, of course, no one size is going to fit all when it comes to cybersecurity mitigations and then, of course, safety mitigations, because they can interfere and interact with each other. Next slide, please. So IoT is also a little bit different than what we normally are using in our, wherever we might be, right? If it's a traditional computing device, we're going to notice differences in how that device, an IoT device, operates, right? Like a drone, I don't know, it doesn't have a keyboard. None of these have keyboards that we look at right here, right? The thermostat might have a touch screen, and then the fridge may have a touch screen, but then likewise from maybe the more OT side of it as well, they also look different, but sometimes not different enough. And whether or not there's that internet connectivity, even with digital components like a screen, say, right, a monitor can exist on a device, on a product, without there being any internet, without there being any network connection. Therefore, in our definition, not making it, or our description, not making it an IoT device, not to say it doesn't have any considerations, possibly still has cybersecurity considerations, but they're not network-related cybersecurity considerations, at least most likely. That they're going to be related to more hardware, software, perhaps. And so that creates challenges in just knowing if you're dealing with IoT from a consumer perspective, and kind of thinking back to how AI might be making decisions, it adds even more complexity if you're looking back to see something went wrong or some sort of safety issue occurred, how and why. It may be easy to determine that the connectivity is possible, but was the device connected at a certain time when something happened? And what kind of data, kind of thinking to Mark's presentation, what kind of data might you be able to collect, in this case, not from social media, but perhaps, but also from the device itself, logs and things like that, that may still be unstructured data that you have to look at as a human or as a model to really figure out the root cause. But IoT, the way these devices are architected sometimes, as we're about to see, create some challenges there. So next slide, please. And just to lay the ground for the next few slides, I'm going to go through a few examples of expectations in cybersecurity that have been broken and some connection to how that might impact safety and all. We think about this as, well, this is from our document NIST 8228. We can share the link for that. I just wanted to highlight that since there's a lot more on the slide that I'm going to talk to. The top level is really what I wanted to highlight is, and this applies beyond privacy as well, I would say. From cybersecurity, these first two, device security and data security, are those big areas besides the traditional view of confidentiality, integrity, and assurance. But with IoT, you want to make sure the device is going to operate as you expect. Kind of like that, how the algorithm, the analysis side of what Mark talked about. Like that's the part we're talking about there, right? Ignore the data, right? Like just, is it acting weird? And sometimes it's not related to bad data. It might be a bad algorithm, might be a bad update, might be a bad protocol being followed in the system. It's not always related to data in cybersecurity, and that was something we were trying to highlight here. And then building on that, though, is like if you know your device operates well, if you know that in all the cases you could possibly test, and you've tested as many as you possibly can, and you have an algorithm that can adapt even to complex situations, and a device that can do that, you still need to make sure the data, there isn't garbage being fed in. Because if you manipulate that data stream, and even if there aren't enough control states, you can manipulate what control states are being accessed. To, again, go back to Mark's presentation, put it in those terms. And that's a cybersecurity concern as well, because you're losing your control, your autonomy as a user of the device, and how you want that device to operate. You don't expect that to happen. And then privacy builds up from that. I'm not here to discuss privacy, but safety would also build on that once those assurances are met. Next slide, please. So folks may remember the Mirai botnet attack. We like to highlight that one as a great example where the expectation, one of the most basic cybersecurity expectations, a device I'm looking at, this laptop right here, I can put a password on it, I can lock it down, my organization has locked it down thoroughly to minimize local access privileges, only I can use it and only I can tell what to do, and even I can only tell it certain things. But IoT devices, unfortunately, in large scales, sometimes break that expectation. And Mirai and other botnets are a good example of that, where I don't know if many users expect the botnet to be part of the use case. Next slide, please. The next one we have here is kind of an expectation of continuous updates, right? I have Windows, I expect Windows to keep being updated over time, and generally it is. I get firmware updates and all that. It ends at a certain point, it's sunsetted, but it's well known, it's well publicized. IoT devices, again, unfortunately, for various reasons, aren't always supported as well in the long term, which creates this higher probability of there being outdated, vulnerable devices out there. Next slide, please. As I highlighted, IoT devices, especially when you think about safety, are going to operate in the real world. And so physical controls aren't, I don't expect there to be many physical controls on my laptop, tough book maybe, but a generalized laptop, it is what it is. But stove, right? There are certain physical controls in that operational side that are really key. A lock, similarly, would have things beyond just cyber, but if you can hack into it and then steal the encryption key, it becomes a cyber attack as well. Next slide, please. And finally, I highlighted this one at the top, so we don't need to dig too much into it, but those traditional interfaces you expect might not be there. So, am I supposed to say my password to authenticate to something that's a voice authenticator, or what is the authentication procedure there? Certain baseline cybersecurity capabilities are going to be fundamentally different in IoT versus IT or even an OT system. And then next slide, this will be my last slide. Just kind of wrapping up, just want to remind everyone of, again, I had to go through a little quick on the end here. We can cover it if you have questions in the Q&A later. IoT and AI they're connected and maybe sometimes intertwined. One product, right, that edge device maybe may have an AI algorithm built into it. So it's collecting data, reacting to data in automated ways that a user has control over to some degree, but naturally, because of the way AI works, may not have complete control over. And that creates this, the scale of IoT can amplify those sorts of decisions, and that actuation can really can hurt people and it can hurt their safety. So that was all I had for today. I appreciate the time, and I look forward to answering Q&A later on.
Thank you. Okay. Thank you, Mike. Next, we have Serge Leontiev, Master Principal Solution Architect at Oracle. With over 25 years of extensive hands-on IT experience, Serge has been with Oracle for almost 10 years and spent a couple of years outside Oracle, leading technical product marketing and high-paced database startups such as DataStax, Dremio, and ScyllaDB. At Oracle, Serge is supporting various pre-sales activities, helping to develop future-proof strategies and solutions for federal and civilian customers around emerging technologies such as AI, ML, IoT, blockchain, etc. Earlier in his career, Serge served as an IT consultant, developing lead and architect for various federal government agencies, including the U.S. Army, NIH, and the Census Bureau. Serge, the floor is yours.
Excellent. Thank you so much. Thank you guys for having me here. Two previous presentations were great, basically talking about all those AI capabilities, IoT capabilities, which is kind of driving all those data and to decision making. During my session, I would like to talk about how we can innovate with the cloud, right? Because obviously for all those computations, you need a very powerful machines underneath the hood, right? And next slide, please. So with kind of going outside of your traditional database and application data, right, where you can easily get access to well-structured data like orders, consumer information, kind of complaints and all the stuff, to semi-structural or unstructured data, complexity of the data processing will definitely get more complicated, right? So going through the social media feeds, going through the transcripts or the phone calls, reviewing the different data sets from the different sensors, obviously increasing complexity of data computations. And you need to take that into consideration when you're kind of building all those algorithms and going through the data sets. Next slide, please. And so we kind of been talking with our customers and what actually customers want for their production AI. First of all, people actually looking for AI that works for your use cases, for your scenarios, that basically can help to identify issues with particular product in your particular case, or increase. So we've been talking with some other kind of government agency. They're looking for public safety, right? The transportation, for example, right? Making sure that traffic patterns, light patterns in a certain part of the city aligned and providing like a safe environment for the people. So basically, they're looking for pre-trained and customizable models that are applicable for their use cases. Also, collaboration is important. Ability for different data scientists, a group of data scientists to work together and work on the data models and being able to publish, reuse data sets, and they properly apply all those labels and data sets and build consistent API is crucial as well. And most important, our customers looking for open and extensible platform, not to be locked into proprietary solution, for example. There's a lot of open source frameworks that data scientists are using in day-to-day life, and the ability to run all those workloads anywhere, AI models anywhere, is very important. Next slide, please. So obviously, all the stuff requires heavy computing powers, right? So, and what we define as infrastructure for the heavy compute. So we have like different areas like a big data that's serving basically business use cases, customer side, consumer protections. It could have a lot of unstructured data stored on external storage. There's a scale out use cases that are applicable for live streaming, data telemetry, and other kind of on-demand heavy workloads. And there is a high performance computing, basically aggregated computing power and storage that delivers high performance to solve complex computations and basically to solve engineering problems. In this particular case, like a parallel use cases, risk simulations, safety related kind of scenarios, and contextual search and logistics and simulation, weather forecasting, those type of scenarios definitely requires high performance computing. Next slide. So this is basically the definition of the high performance computing, right? So like I mentioned before, we're referring to that term as kind of aggregating computing power and storage in a way that deliver high level of performance to solve complex computations or problem. It's mean that at the end of the day, if you have that under your hands, right, so you will be able to spend less time on prototyping, right, faster develop all those machine learning algorithms, and you will be able to deliver those algorithms very in a fast manner. Next slide, please. So there are the obvious challenges for on-premises high-performance computing. A lot of organizations opt in to kind of host all these infrastructures by themselves. Nothing wrong with that. However, you will be running into a lot of issues. For example, capacity planning. So how you can correctly balance capacity that basically you need for your on-demand workload needs. Sometimes it's really hard to predict if you need like a lot of resources for certain period of times. Sometimes those resources just sitting there and doing nothing. Supply chain actually can affect in delays, right? So if you need additional computing capacities and you're ordering additional rack, supply chains issues, all the stuff can definitely affect you. Cost, right? If you kind of aiming at high performance and predicting your capacity, you may over provision resources. Basically, we'll spend a lot of time and money on the on a kind of supporting that hardware, and the hardware basically will age with time, right? So it become less powerful, less kind of out of date, and it's hard to optimize operations. Usually HPC farms must run like at the nearest capacity to maximize return of investment, which is kind of will be not possible. And under provisioning again will cause some issues. We've been working with UCLA, and they were building some computer vision algorithms for their use cases, again to kind of provide safe environment for city of LA for citizens, right, to detect like a danger on the road, such as kind of abandoned vehicles or stuff that have been dumped on the road. And they were running a farm of computers, and it took like days for sometimes to run all those computations. And with like when they moved from the on-premise to the cloud, they were able to solve those problems and get their results within hour or less. Next slide, please. So basically, an HPC market is growing, as you know, right? So there is like different kind of references to different analyst firms that basically suggesting and predicting that the cloud is the fastest growing segment for HPC market. And a lot of companies will move their workloads from on-premises to the cloud. Next slide. Which basically takes us to this particular slide, right? How customer would benefit from moving high performance workload to the cloud, right? But first of all, the cost. You will reduce on-premise infrastructure, and you can use on-demand capabilities of the cloud, elasticity of the cloud to add additional capacity, right? And get the performance that you're looking for. Instead of, like I mentioned before, spending days to run your model prediction algorithm, you can solve it in an hours, right, or less. And that will give you more kind of flexibility to apply different algorithms to validate your models, validate your assumptions. Next slide. So how we can ensure the success with data science? We're trying to kind of see to make data science and data scientists productive, right? We're trying to make sure that they have all power at their fingertips to create and validate high quality models, so they can embed those models in the data sets and build what they're looking for. And again, work with data, with all data that you need for better results. So if you have like a distributed data sources, for example, some data on premises, some data in the cloud, it will be harder. But if you are using these data sets that's basically all in one places, and you have access to the data, it will be much faster and easier to produce result that you're looking for. And again, deliver trusted AI, basically valid to previous conversation, right? So how we can trust AI? So you need to validate all those algorithms and make sure that they are doing what they're supposed to do. Next slide. So again, so machine learning, obviously, from that point of view, is better in cloud. You will get access basically in its cloud environment to high performance compute that you might not be able to afford to build on premises. You can choose from the flexible shapes from VMs, virtual machines, to leverage a bare metal rack, right, for a very high demanding workload. And obviously you can deliver better performance than on premises. The GPU will be cheaper, right, because you're not buying the GPU as part of your infrastructure. You're just using it as needed on a needed basis. The storage obviously will do kind of give you more flexibility and performance. The cloud storage basically grows, and the cloud providers always keeping with up to date, giving you access to SSD drives, right? Object storage, block storage that you can leverage for your data. You can build data lake with 90% lower cost compared to the on-premises. And the network performance, basically, since everything running in the cloud data centers, you can definitely get a better, lower latency and better performance. And keep in mind, right? So, for example, when you're using your smartphone, smart devices, when you're trying to do some basic stuff like AR, augmented reality, or different type of search, all those computations actually done in the cloud. So the device just sending information, whatever image you captured from your phone to the cloud. Cloud does all those computation and returning that back to your device. Next slide, please. We're going to skip through those slides. Just kind of the point of the slides to highlight, right? So whenever you leveraging cloud infrastructure, we trying to, or not we, any cloud provider basically will try to make it easier, right? Easier to access and ingest data. That's very important. If you have like different data sources, like I mentioned in my first slide, coming from structured to unstructured data, being able to discover that data, create a catalog, explore and prepare data is crucial, right? Giving you ability to use different tools to automate data preparation, to ingest data and visualize data is very important. Next slide. Then definitely you would need a kind of high quality model. How are you going to build those models? So there's a bunch of frameworks that's available and for model evaluation explanations, and having those frameworks at your fingertips instead of spending times on kind of building that environment on premises or provisioning environment. You can use already pre-provisioned kind of virtual machines, right, or images that will speed up your data science experiments. Next one. And again, so like I mentioned before, that all data may not be in one place. It could be just people sometimes using a multi-cloud strategy. They can store it in different clouds, and in our case, Oracle Cloud, Azure, AWS, Google, or on premises. And it's really, really important kind of to ensure interconnectivity and being able to tap into existing enterprise data sources, into SaaS applications, analyze graph and analytics outputs, and been able to communicate with third-party data as well. Next slide. So, which basically bring us again to the previous, to the beginning of our conversation, how we can deliver trusted AI for enterprises. And again, so we need to kind of give a team of data scientists the ways so that they can collaborate with each other to be able to do data exploration, data modeling, data validation, deployment all those models in a cloud environment, monitor and refresh or retire models as needed, and being able to access data in a very fast and efficient manner. Next slide. So basically, we're talking about cloud as a cloud data science platform, basically machine learning platform that supports any data sources, can ingest and manage and do analytics on any kind of different data sets, right? Basically, that may be in databases, in a data lakes. You will have a catalogs and visualization capabilities to see all those data. And then you can use actually data science and machine learning framework to build algorithms. So for example, yes, from the, again, referring to your particular field, from a consumer perspective, and it was like a good example, reviewing all those data feeds from the social media, complaining about the product, will become easy task, right? Because you will be able to do all the stuff in one place and leverage the high performance computing underneath the hood, or rely on the data that's coming from the different sources and deliver that outcome to your applications or business analytics processes. The last slide, just to highlight that at Oracle, we kind of understanding and seeing that challenges, we're trying to build all the services, not to pitch our cloud platform because our competitors definitely have the same, but point is, right? So whenever you're looking at the cloud, you may find that machine learning services are there for you to consume. And even better, some kind of the cloud providers building even AI services, predefined algorithms. For example, digital assistant that you can use, chatbots that you can use to interact with your customers, handle complaints, and create a kind of outcome based on the customer complaints. OCI language, where you can go through the text and do like a sentiment analysis, right? So if customer is not happy or happy about particular product, speech recognition, right? Sometimes the only way for you to get data through the speech, you can do that. Vision, you can analyze images of the product, for example, and detect possible issues with safety. You can do that. Anomaly detection, when you see like a data going out of trend, that's been done for many iterations. Again, could be tied up to the IoT, and forecasting. So last slide, basically to conclude my presentation, you should think about moving your kind of high computation resource extensive workload to the cloud, because you will get access to the best hardware, best software, and you can be more productive that way. Thank you so much.
Thank you, Serge. I want to take a moment to thank our panelists, and I know our attendees can unmute themselves, but I'll do a round of applause on behalf of the attendees. We will now take a 10-minute break. During the break, we will play several CPSC videos on general consumer product safety. Once again, the forum will begin in approximately 10 minutes with the products panel. Thank you.
As we all shelter in place, CPSC has a few tips to keep your family safe at home. Laundry packets, disinfectants, and medicines should stay in original bottles and put out of reach of children. Test your smoke and carbon monoxide alarms and develop a fire escape plan. Keep high-powered magnets away from children. Prevent dangerous tip-over incidents. Anchor large furniture and TVs to the wall. Stay healthy. Stay safe. Find specialized tips for all age groups at cpsc.gov.
Hurricane season is in full swing, and CPSC has 3 tips to help you weather the storm. First, keep generators at least 20 feet away from your home when in use. Carbon monoxide is the invisible killer. It's colorless and odorless, so keep exhaust away from windows, doors, and vents. Second, make sure your smoke and carbon monoxide alarms have fresh batteries and they work properly. Third, place CO alarms outside sleeping areas on each floor of your home. Follow these tips to keep your family safe. A friendly reminder from your friends at CPSC.
Oops. Uh-oh. Sorry.
Get on top of it before they do. Every 24 minutes, tipped furniture or a falling TV sends an injured child to the emergency room. Preventing tip-over incidents is easy, inexpensive, and only takes 5 minutes. Learn how to secure your furniture and TVs to protect children at anchorit.gov.
Chance was loud. She was playful. Chance loved to dance and sing. She loved playing with her brother. Chance never met a stranger. She was just an awesome, beautiful little girl. She said, "I love you, Mama." I said, "Well, I love you too, Chance." I never thought that would be the last thing that I heard her say. I went into the room, and that's when I saw where the dresser was on top of her. I just screamed her name. I kept saying her name over and over and over again. I was like, "Chance, Chance, Chance, say something to me, Chance." The doctor came in and told us the TV falling on her was like her falling from a 10-story building. You're not supposed to bury your child. And so for this to happen, and it could have been prevented. We know God has a purpose and God has a plan for everything. But if we had known the steps that we could have taken, maybe it wouldn't have happened. We didn't know that you can buy straps to anchor those dressers. If we can tell one person and one person anchors their TVs and they fasten their dressers and furniture down, Chance's mission and Chance's purpose has been served. We don't want this to happen to anybody else. Don't take a chance on this happening to you, because no parent should ever have to go through this.
The last conversation I had with her was, "Good night, Mommy, I love you." 5 o'clock in the morning, I woke up to the sound of the TV falling. I did not know she was underneath it. So I called her name, "Janiyah, Janiyah, where are you?" And I turned around and I just saw her legs under the TV. You just don't think of televisions or bolting your dressers to the wall. You don't think of those things. They don't tell you to do that when you get out of the hospital with your baby. You need a car seat, but they don't tell you when your child starts walking, make sure your furniture is bolted down.
The majority of furniture tip-over injuries occur in the home to children 5 years and younger. Most devastating injuries that we see to children because of furniture tip-over are injuries to the brain, and also when a child is trapped underneath a heavy piece of furniture and suffocates. And the most important thing for parents to know is that most, if not all, of these injuries are preventable.
I urge parents to include securing TVs, furniture, and appliances in their childproofing efforts. Taking a few moments now to anchor and secure TVs, furniture, and appliances can prevent a tip-over tragedy later.
A television can be a child's best friend, but it can also be a parent's worst enemy.
Are your window coverings safe? Corded window coverings are one of the top 5 hidden hazards in the home. About once a month, a child dies from window cord strangulation. CPSC has recalled millions of window coverings in recent years. Window covering cords present the following deadly hazards. A child can wrap the pull cords around the neck and strangle. Or, if cords become entangled themselves or are knotted, a loop is formed in which a child can strangle. A child's neck can become entangled on a freestanding nylon loop or beaded chain. With Roman shades, strangulation hazards exist between the exposed inner cord and the fabric on the backside, or when a child pulls the inner cord. With roll-up blinds, strangulation can occur if the child's neck is trapped between the lifting loop and the blind's material, or if the child's neck becomes entangled in the freestanding loop. Additionally, strangulation can occur if a child pulls on the inner cord of a window blind. Consumers should examine all window coverings in their homes. Make sure there are no accessible cords on the front, side, or back of the product. CPSC recommends the use of cordless window coverings in all homes where children live or visit. For more information, visit cpsc.gov.
Welcome back, everyone. As a reminder, this forum will be recorded and potentially made available to the public. Also, we ask that all questions be held until the Q&A panel later today. Next, we have a panel on AI and ML products moderated by Simon Lee. Simon?
Hi everyone, I'm inland today. Gonna see if we can find some fossils in a site I saw in Google Earth about 2 miles to go, 3 kilometers. But in the meantime, I found something. Saw this concretion looking rock over here and picked it up, and it's a slime kernel.
Simon, you're on mute. Bear with us, folks. We seem to be having just some technical difficulties. Please allow me to kick off the products panel until they are resolved. Our first speaker today is Dr. Gil Altovitz, who is the inaugural director of the National Artificial Intelligence Institute at the U.S. Department of Veterans Affairs. He is focusing on leveraging health information for AI, as well as building AI research and development capacity to help our nation's veterans through the Office of Research and Development. He is also a faculty member with Harvard Medical School. Dr. Altovitz was one of the core authors of the White House Office of Science and Technology and Policy's National AI R&D Strategic Plan from 2019. He has also spearheaded the AI-able data ecosystem pilot creating a new approach for public-private collaborations with personnel resources across a dozen agencies and working with companies internationally. Without further ado, Dr. Altovitz.
Well, thank you very much, Nevin Taylor, for the introduction, and looking forward to speaking today to you. We're going to take a look at evaluating some of the AI pilots that we're working on for our veterans. And one of the things we're going to try to emphasize is around some of the consumer safety issues that we think about, where users of these different AI products may be physicians, they may be veterans, they may be caregivers, families, and others. And so let's move to the next slide then. So, why AI at the VA? Well, there's over 9 million people, veterans, who are potentially served or are currently served within the VA. The VA is actually the largest integrated healthcare system in the United States, and there's over 120,000 clinicians. Actually, the majority of U.S. doctors, about 3/4 of them actually do some or a part of their training within the VA, or are actually participating in the care of patients within the VA at some point in their career. There's also over 1,000 medical facilities across the country. So there's really a breadth of information available as well. There's about 1 billion new images generated each year. There's about 10 billion medical images overall. So it's one of the world's largest medical image repositories. Genomic, other piece of information, all that can help serve in this mission. As we know, that data is really the critical part of building AI models. And that AI model, in some sense, is just a representation of that data in many ways. Let's go to the next slide. So now we'll talk about some of the AI pilots and take a look. I'll try to comment where applicable on how they may affect different consumers, whether it be veterans in some cases, others, like I mentioned, physicians, caregivers, and so forth. Let's go to the next slide then. So when we think about taking AI research and taking it to production, there's really kind of a life cycle, if you will. And even though this is kind of drawn linearly here, if you see at the end, there's sort of that update cycle. It really is a cycle. Is the best way to think about it. And so taking that existing data that's already there, demonstrating usefulness, a proof of concept, then taking it to a pilot, maybe at one site, maybe just a couple sites, expanding that, scaling that all the way to production. I think in this slide, it has a kind of update at the very end there. I think in some sense, there's an update throughout the whole process. That's what we've seen. I'll go through one example of that in a little bit. And it's really important to kind of regularly monitor and update both the models, the processes, the training for workforce that's involved, and so forth. And in fact, the idea of regular monitoring is one that's encoded in the Trustworthy AI Executive Orders 9 principles that were developed for agencies to follow to ensure safety when executing AI within their mission. Let's take a look at the next slide then, where we'll actually go through an example where we created this COVID-19 108-day morbidity and mortality model, piloting some of the ideas around trustworthy AI. And it's really interesting. We've learned a lot from it. We work with a number of different medical centers, initially the Washington, D.C. one, but now received feedback, integrated feedback from over 13 medical centers. And basically, this model helps identify high-risk patients. It takes a look at what type of care, what kind of operational needs might be done. And what we're seeing is, and this is kind of leads you to see why it's important to continuously audit, regularly monitor the models and so forth, is that throughout the pandemic, we've seen shifts in the data, right? Because it's not only new variants that are coming out, it's also new treatments that affect how the patients then respond, right? It's also new ways that operationally resources are allocated, and supply chain, other things that come into play, all of which together lead to models needing to be updated and changed, leading to new types of data to be integrated into models. And so it's really important to think about that when you're thinking about safety for consumer types of products, is thinking about safety, thinking about the model, its development from the very beginning to ensure that it's you're using and embedding trustworthy AI at the beginning, and that you regularly look and see how the data, how different facets that affect the model and its use are changing over time, so you can update accordingly. Let's go to the next slide, which goes through a couple more details here. And so, you know, as was mentioned, you know, this aggregates multiple data sources, and with time we can add more data sources, and it can be useful for supporting operations, strategic planning, even palliative care coordination. So this is kind of one example where we've looked at this. Another aspect of this is, which is part of trustworthy AI, is, you know, ensuring that the model is understandable, and we've kind of looked at one step beyond kind of understandable, is to really make it explainable AI, so that clinicians can understand why the model is, what parts of the data it's using in determining and making its recommendations. What are the important variables? And that can be useful not only for people who are actively making decisions, but also in training physicians and others who are looking at these models to understand how changes in the data and changes over time can affect decisions that need to be made. Because, you know, if a clinician, for example, adopts a certain way of thinking and new types of data become available, or there's a new variant and it affects a different population, like some of the newer variants are affecting more younger children, then you know, this is able to flag some of those and see how things are changing over time that this physician may not have realized, or may not have seen, and may have assumed that the model in their own head that they developed based on the patients that they've seen, you know, remains the same. But these things are changing over time, much more rapidly than, you know, you've seen in traditional, you know, diseases where, you know, the training you have in medical school, you know, may be that, you know, it takes 5 or 10 years before kind of the model that you have in your head of how to treat the patient and deal with things would occur. Now, in a pandemic like this, with quickly changing variations, standard of care, practices, treatments that become available, there are a lot of changes that happen much more quickly, and there isn't kind of essentially enough time for them to go to their continuing medical education to learn that, and this can help them kind of see those changes more quickly, essentially almost like a simulation. I think in some of the videos, I'm not sure if it was one that's shown now or later, you'll see many times an agency will create simulations to look at safety and so forth, and this can be done to do that. Let's go to the next slide then. And we actually kind of went over this, but, you know, we're engaging other parts of the VA to, you know, further enhance the tool, get user feedback on the interface, you know, making sure it's useful and things like that. And the reason I want to put this slide is that the interface to the product, whether it's used by a consumer, maybe the physician, or, you know, in some cases later we'll see could be the patient. When you know, present data information, when you solicit kind of inputs to the system, it's really important to have that interface be informative and designed for that audience that you have in mind. So, when we develop this and we are working on this, there are certain metrics that were presented that, the clinicians were like, yeah, that's pretty interesting, but how does that translate to, X, Y, and Z, which is the way they were thinking about things. And so that is also important when you're thinking about how to, present and receive information that could affect safety. Let's go to the next slide then, where we're talking just in generalization, a little bit in general here about AI-driven systems for centralized data and analytics. You want to think about there are a number of ways to approach that. You could have centralization of the data. It's the data itself, but also thinking about physical co-location of key individuals. There's a number of studies that have found that when people are co-located, they are more likely to publish together, to work together on items that lead to a bigger impact. Now, there are a number of new technologies now that allow people to work virtually as well, and I know there are studies kind of looking into how that can influence things, but centralization of data and/or people is something to potentially consider. There are other alternative ways like federated, learning approaches as well to think about, but that's kind of one area. And then the second is looking at increased operational efficiency. So, there's a large impact on operational efficiency, and that you could have on bed space management, quality of care, patient experience, clinician satisfaction. All of these are possible by having an AI model, like I mentioned before, and transparency, right? It can capture why some of those decisions are being made. It can help coordinate between different parts of the organization through having a common medium to communicate some of the decision processes. And AI-powered systems really allow us to enhance the outcomes for the veterans. That's really the ultimate goal, right? Is to enhance the outcome, right? And so AI is just one approach to doing that, making things more efficient, having better outcomes, potentially cost savings, preventing or helping reduce physician burnout. These are some of the benefits from this. And in doing so, it indirectly also helps on safety issues, right? Because if you are preventing physician burnout, you prevent issues like misdiagnoses or procedures that are done incorrectly because the physician is, if there's a burnout or a lack of resources that can be allocated at a given time. Let's go to the next slide then, where we talk about another example, collaboration. This one is about acute kidney injury. So what you have here is there's certain conditions where people can have acute kidney injury. If you can predict it 48 hours in advance, you can actually prevent the clinically observable symptoms from coming about and essentially prevent the disease from being diagnosed. It's almost as if you prevented the disease from happening in the first place. I mean, what's really going on is that you're able to detect preclinical symptoms with this AI-based system that was developed, and as you can see, published in Nature, that the VA recently got back as a model that it can take a look at and use and learn from and use for training purposes as well, right? So another area where you can kind of enhance, have enhanced capabilities by looking at patterns with AI that physicians in the past have not been able to do, but by looking at large data sets, it's able to find these patterns before physicians have been able to, typically in the past, and thereby prevent this episode from occurring before it leads to clinical symptoms that are irreversible. Let's go to the next slide then. Another area I think that's important to think about in safety is around medications. So it's one thing to give a medication, you can prescribe the medication, but if the patient's not taking the medication, or if the person is taking the wrong medications or in incorrect doses, you can have some serious safety issues. And in fact, non-adherence to medications can account for up to 50% of treatment failures, and around 125,000 deaths and up to 25% of hospitalizations each year in the US. So if we go to the next slide, we'll see that this one application that came out of one of our AI tech sprints actually worked to address that particular issue, medication adherence. What this solution does, let's go actually to the next slide in the interest of time. We should be able to see a video there where you see someone on their phone is able to, just using the video feature, shine that onto, you can see there, they just have some medication there on a table on the laptop. The camera automatically, using AI machine vision, identifies those medications based on what those pills look like. And then in the background, if the veteran consents ahead of time, enables the application to see what medications the veteran is signed up to was prescribed, right? And sees if there's a match there. If there's not a match, if there's unknown medications or they're missing medication, it can alert the veteran right there. And so there's a number of ways that this can be useful, both for the veteran, the caregiver, as well as for physicians, because sometimes when they prescribe, that item doesn't end up in the medical record, or it may be that they were prescribed outside the VA system in some way that it didn't get into the system, or they're not taking it anymore. And so this allows all the parties to be in sync about those medications. And that's really important, not only for making sure they're taking the medications, but to make sure there aren't interactions between medications, or that a surgery that is done, that they're not on a particular medication that can interfere with that surgery or procedure. So a lot of different areas where an application like this can play a role. So let's go then to our follow-up slide, where I think we have a couple of minutes. I think we to go over a couple more. Suicidal ideation detection, another example where really the important key here was around ensuring reduction in false positive rates. So there is a way right now, which is kind of a rule-based, simpler approach, but the problem there is you have a lot of false positives. It's just looking kind of, you can look for keywords, but not kind of some of the context. And so you end up getting a lot, as I mentioned, false positives, but with some natural language processing approaches, you can get more accurate filtering and thereby ensure that you get faster triaging and care to the consumer much more quickly. Let's go to the next slide then, where we're talking a little bit about remote monitoring in health. I showed you that first application around medication reconciliation. That's the idea of making sure that you're taking the medications that you're supposed to and so forth. But there are a number of other cases, right? You can allow for monitoring with long COVID while reducing the need for in-person care. That medication reconciliation can allow you to reduce the need for additional visits. You can kind of solve, which take time to schedule and so forth, right? You can do that much more quickly. So there are a number of these that are possible, looking at gathering information about symptoms and facilitating that communication between provider and patient in a way that when you increase that communication, you can reduce the risk for errors and safety issues. Let's go to the next slide in the interest of time. One example is a physical therapy app, where you have a therapy app where you can take the data source agnostic and have a number of pieces of information coming together and leveraging wearable type of information. And that can allow you to monitor that rehabilitation protocol remotely, whether it's gait monitoring, things like that, and or prediction of overuse injuries, so that you can allow the veteran, the consumer, to be with their family, to be away from the hospital, and to have more time, but at the same time ensuring the safety by doing that monitoring if they so choose to do that. So it's another example of an application that's being looked at. So I think in the interest of time, let's go to the next slide and kind of we should be, or we kind of went through the mental health app, so it's in interest of time. let's go to our next slide, where just want to really close. Thank everyone. There are a number of ways if people are interested to engage more on some of these items or others. We have an AIADV community where there's a newsletter people can read more, engage together. Always feel free to email us at iadv.gov if people have questions. But with that, I'll close here, try to make it back for, there's I guess a Q&A later today. And with that, pass over to Simon Lee. Thank you, everyone.
Thank you so much, Dr. Alberts. I apologize for those technical difficulties. Our next speaker is Dr. Tracy Sanders from MITRE. She holds a PhD in Applied Experimental and Human Factors Psychology and an MS in Modeling and Simulation from the University of Central Florida. Her research interests include human automation interaction, user-centered design, and artificial intelligence. Tracy uses empirical methods to solve complex problems and advocate for the needs of users in a variety of domains across government and private industry, including aviation and ground transportation, autonomous systems, and accessibility. In addition to her role as a human-centered engineering lead at MITRE, she's a part-time professor at Maryland Institute College of Art in Baltimore. Thank you so much, Tracy, for joining us.
Thank you. Thank you very much for the introduction. As Simon mentioned, I'm a human factors engineer at the MITRE Corporation, and I'm really interested in how people use technology, including AI, to improve their lives and their work. And I developed this work with Elizabeth Karpinski, who is a data scientist at MITRE. Next slide, please. So today I'm going to talk about micromobility. Micromobility refers to small, lightweight transportation devices, including bikes, scooters, e-bikes, e-scooters. This term was coined by technology futurist Horace Dediu, and he used it to refer to transportation vehicles under 1,000 pounds. But the definition has tightened up over the last couple of years to exclude some of the larger devices like golf carts, as well as mobility devices for the disabled, such as electric wheelchairs. Now, shared micromobility refers to devices that can be rented. Sometimes these are docked, meaning that you have to pick them up and return them from the same location or specific locations, but other times they're dockless, meaning that you have more freedom on where you can leave them and where you can find them. This is generally the case with e-scooters, and e-scooters are what I'm going to be focusing on today. So we're interested in e-scooters because they've been rapidly expanding in dense urban areas. E-scooters began appearing in US markets in 2017, and by 2019, they were in 115 US cities. So my team at MITRE has looked into this extensively from a few perspectives. We performed an in-depth literature search that included scholarly articles, reports on pilot programs that various cities conducted, a review of rules and regulations pertaining to e-scooters, both from the device provider's perspective and the rider's perspective as well. And then we also looked at contracting mechanisms between city and device providers. We did interviews with micromobility program planners across the country, with transportation experts and industry professionals. And we've done a deep dive into the safety data to try to understand how data from this emerging transportation mode can be standardized and accurately compared to existing modes of transportation. We've published a number of peer-reviewed journal articles and stood up a website at micromobility.mitre.org to better disseminate the research to the planners on the ground who can use the information, for researchers and people in the community who are just curious about micromobility. So in this presentation, I'm going to cover why people are interested, why we're interested in e-scooters, who is affected by this technology, and how the technologies powering e-scooters are built on AI. Then I'm going to talk a little bit about what's next for micromobility and the relevant research needs that still remain. Okay, so first, why micromobility? And the main reason that we're interested in micromobility, or that micromobility is important, is efficiency. When we talk about efficiency, we mean energy conservation. A significant amount of American carbon emissions come from transportation, and most of the resources that are involved in using a car for transportation purposes are only necessary because of the size and the weight of the car itself. So it's inherently inefficient. Micromobility could be a great alternative for a lot of short trips. So there's also financial efficiency. Micromobility is cheaper and less capable of causing damage, so less expensive to insure. There's just a general lower financial threshold. It's a lot easier to get access to a scooter than it is to get a car. And lastly, it's efficient in terms of space. So micromobility devices take up less space in a crowded system for both transportation and for storage. All right, next slide, please. So who is affected? Like any transportation mode, e-scooters don't exist in a vacuum. And we're not just interested in how e-scooters impact the users riding the devices. We wanted to get a sense of how it's affecting the whole ecosystem around the rider. So we want to understand who these non-riders or bystanders are, what they need, and a little bit of what they're responsible for. We categorize these bystanders into three big groups: other vulnerable road users, motor vehicle drivers, and community members. So other vulnerable road users includes other micromobility users, including other e-scooter riders, cyclists, skateboarders. It also includes pedestrians and people using assistive devices like wheelchairs. These people need to be able to have good expectations for what an e-scooter is going to do. And similarly, they need to act predictably themselves. So the next category is motor vehicle drivers. This includes privately owned vehicles, public transit, commercial vehicles. And these motor vehicles can be completely controlled by the human driver, or they can be driverless autonomous vehicles, or more likely they're somewhere in between. And vehicles aren't just on the roads and in parking lots. In many places, delivery bots travel on the sidewalks, and they can interact with e-scooter riders there as well. So drivers need e-scooters to behave predictably so that they can have appropriate expectations about what's going on and what's going to happen next. Since motor vehicles are the heaviest and largest vehicles in the system, they're also the most dangerous. And for this reason, drivers have to maintain constant awareness of their environments and expect the unexpected from more vulnerable road users. And lastly, there's community members. So community members don't necessarily interact with e-scooters or their riders at all, but they're still affected by the presence of e-scooters in their communities. There are obvious effects like devices cluttering up sidewalks or making it difficult to get by, but there are also less obvious effects like jobs in the community, the reduced emissions that can be caused when people use micromobility, and then conversely, the environmental damage that can be caused when vandals attack these devices by throwing them in bodies of water or setting them on fire. Community members need e-scooter riders to be responsible and follow safety rules and be conscientious in terms not just of their riding, but their parking. Community members are responsible for staying informed and making their wants and needs known by participating in community events. Next slide, please. So now I'm going to talk about a technology journey of using an e-scooter. Unlike older forms of micromobility like bikes and skateboards, which could be operated totally manually with no electronics, shared e-scooters use AI technologies for both the sharing and the operating aspects of their operation. So for instance, let's say you want to rent an e-scooter. The first thing you're going to do is get an app if you don't already have it. This app uses many AI features in order to function. For instance, it's going to use geolocation to find you, and it's also going to use geolocation to find the nearest scooter to your location. Next, you're going to acquire the scooter and rent it. So to do this, you're probably going to have to provide verification of your age and your identity through the app. There's also going to be some kind of payment mechanism involved, and payment will be verified before you can actually use the scooter. And now that you've done all that, you're going to ride the scooter. This involves not only AI through the app, but AI in the scooter itself. It's going to use geolocation to constantly track where you are, sometimes down to the level of whether you're on the street or the sidewalk. It's going to use geofencing technologies to ensure that you don't go beyond an allowed zone. And if you do, it's going to use AI to slow you down and stop the device until you return the device to an allowed location, to the geofenced area. It's also going to manage your speed, possibly based on your location. So in some cities, there are different speeds allowed on the sidewalks than there are on the roads. And then new technologies on the scooter itself are emerging, similar to what's used on motor vehicles, including computer vision and other onboard computing systems. So when you're done with your ride and you're ready to return your device, you again use the app to indicate that you're finished. Geolocation is going to be used to determine where you've left the device, and a lot of times, excuse me, a lot of times there's going to be a verification mechanism to ensure that you've parked correctly and in the appropriate space. AI is also being used behind the scenes. The person charging the scooter uses the app, and the entire network of people supporting the operation is managed through AI. Another way AI is used is to protect your personal data. Complex algorithms are used to ensure that your private trip data and payment information stay private. This is especially important with transportation devices because location information is very sensitive. So as you can see, AI is ever present throughout this process. All right, next slide, please. So what's on the horizon for e-scooters? Various companies are developing advanced driver assistance systems, also known as ADAS, which are similar to what's used in motor vehicles. If you think about adaptive cruise control, lane keeping assist, and automatic braking in your car. These smart systems also allow monitoring of the devices to ensure that they're in good working order. So a few examples of technologies that are being used right now or being tested right now. In an attempt to provide a safer experience for riders while creating less disruption for non-riders, one company has rolled out 2 consecutive levels of automation. The first level in 2020 focused on vehicle health and safety by monitoring battery level and temperature, controlling location and speed, and detecting when a scooter had been knocked over. The next level of automation, which they rolled out in 2021, focused on sidewalk riding and parking validation using a camera and other sensors, and an onboard computing system to detect sidewalk and bike lane riding and automatically validate parking. So another company is conducting a large-scale pilot in Europe that's using computer vision and determining technology to developing technology to detect pedestrians. Another company has equipped their scooters with more than 200 diagnostic sensors that monitor various components, auto-calibrate brake sensors, and provide anti-theft protection. And yet another company is using AI to detect small thermal, electrical, and mechanical anomalies as they happen, to root out maintenance problems and prevent them before they can occur. There's also intelligent integration with intelligent transportation systems, and this is offering some really exciting opportunities for the infrastructure itself to track device locations and automatically share it with other vehicles and other devices in the network, potentially increasing safety. Improvements in battery technology promise to extend the reach of micromobility, allowing these devices to go further on a single charge and reducing their environmental impacts while also saving money. More efficient deployment is also on the horizon. Algorithms that use geolocation and trip data to optimally deploy e-scooters and predict human behavior will improve the efficiency of the overall system. Now, as with any technology product, there have been some issues related to the technology and the AI. One issue was that sudden excessive braking has occurred, and the devices. This is a serious risk to the rider. especially when they're traveling at a higher speed or traveling downhill. Similarly, devices can shut down unexpectedly, and that can potentially cause riders to lose control. This can happen for a number of reasons, including loss of power or leaving the geofenced area. But usually in this case, the stop is gradual. All right, next slide, please. So where do we go from here? It's a really exciting time to be researching e-scooters. We're on the cutting edge of emerging technology. Capabilities that we've never had before are being paired with powerful electric motors and batteries. These devices have the potential to improve people's lives, but we do need more research in these areas, in some of these areas. So today I'll talk about a few areas: behavior, including communication, data reporting and standardization, policy harmonization, infrastructure, adversarial attacks, and device diagnostics. So a lot of the problems with shared micromobility have been related to poor human behavior: improper parking, riding where it's not allowed, weaving in and out of traffic, not obeying the rules of the road. These are some of the issues that you hear about most when people talk about e-scooters. Poor behavior is definitely an issue with any transportation mode, but that behavior can be improved through a combination of incentives and repercussions. The specific levers to affect that change need to be explored more thoroughly so that we can get better rule compliance. Related to behavior is communication. Unfortunately, there are not commonly used methods of communication that e-scooter riders use to let other people know what's going on. While cars have turn signals and cyclists are supposed to use hand signals, neither of those are common for e-scooters. Further, there's a tendency to switch traveling modes, to go from riding and walking or vice versa, and to rapidly change riding location, say from the sidewalk to the street and back again. Without communication, other people just don't know what an e-scooter is going to do, and that's really dangerous. We need predictability in the transportation system so we can all have appropriate expectations. And there needs to be standardization, a standardized method of communication that everyone knows and follows. And then data reporting and standardization, and this is an important one. A lot of numbers are thrown around about how many accidents involving e-scooters occur, but there are serious methodological and standardization issues that make it difficult to compare these findings against each other, much less against published statistics about other forms of transportation. So some data comes from the initial reports that cities released when e-scooters were first deployed. But the rules and regulations, and just as importantly, the understanding of those rules and regulations have come a long way since the initial deployments. So this information is a little bit outdated. Another problem is figuring out how accidents happen so we can better avoid them in the future. This can be a challenge because there's limited information about what was going on when the accident happened or where it occurred. If the accident data comes from police records, it may include how the accident occurred, but this is often dependent on the person taking the record, the officer at the scene. And this person generally has a lot of other responsibilities, possibly including getting help for the injured. So these reports may not be as complete as they could be. There's also limited fields on the forms that they use, and many e-scooter accidents don't involve the police at all, so they get missed. Another source of data that's commonly used for e-scooter accidents is hospital emergency rooms. However, these data often completely lack any context. There's typically no information about what led up to the accident or where it happened. And like police data, emergency room data is also incomplete since many people don't go to the ER to treat an e-scooter injury. Given all the technology that's currently on e-scooters that I talked about before, the providers, the people deploying the e-scooters, would be a great source of accident data. However, they don't make this publicly available to researchers. Policy harmonization, it's important that policies be harmonized between abutting areas so that riders and non-riders know exactly what to expect in various jurisdictions. Infrastructure, there's a lot of infrastructure solutions, but the same solutions don't work for every problem. While adding bike lanes may work in one city, they may not work in another. There's adversarial attacks. So any technology that's using AI and machine learning has a cybersecurity risk. Adversarial attacks on machine learning in motor vehicles have created deceptive inputs that the model classifies incorrectly. Sometimes the driver doesn't even realize this is happening. So as the amount of automation in e-scooters increases, the potential for bad actors to gain control of those devices increases, and we need to understand the risks involved so we can figure out how to mitigate them. And lastly, device diagnostics. As the capabilities for performance and maintenance and testing improve, standardization and benchmarking become more important. So with each improvement, we've got to ask, how does this impact safety, and how well do they really need to function in order to actually constitute an improvement? So by understanding the benefits and challenges involved with e-scooters and quantifying the risks involved, we can create rules, norms, and best practices that will allow us to get the most out of them. All right, last slide, please. And that's all I have to say. Thank you very much for your time.
Thank you so much, Tracy, for your presentation. We'd like to thank both of our panelists for a great presentation, great, thought-provoking, very informative. It's now 11:52. We want to take a break for lunch now. During that time, we want to show some more informative CPSC videos playing, if you so wish to watch them in the background. And we're going to rejoin approximately 1 p.m. So thank you very much.
Pop quiz. What is CPSC?
Something regarding consumers and safety?
Consumer Product Safety Commission.
The U.S. Consumer Product Safety Commission, or CPSC, is a small independent government agency with a large mission. We protect the American public against unreasonable risks of injury or death from consumer products. From toys to cribs, CPSC protects the public by issuing recalls, developing mandatory safety standards, research and testing, product screening at the ports, and developing educational campaigns like Pool Safely and Anchor It. The Consumer Product Safety Commission also provides resources designed to help keep families safe. Get the latest recall information at cpsc.gov or download the new Recall app. Join our neighborhood safety network and download life-saving toolkits for your family and community. Go to saferproducts.gov to research and report unsafe consumer products. Need to talk with someone? Call the CPSC hotline and speak to one of our trained professionals about your product safety concerns. For nearly 50 years, CPSC has put your family safety first because your safety is our business.
larger facility with more high-tech equipment will help the CPSC be more efficient and productive in testing products that could pose a danger to consumers.
I'd like to welcome you to the Outdoor Power Sports Testing Laboratory. This laboratory is equipped with data acquisition equipment as well as this tilt table built into the floor where we perform the parking brake test that is part of the standard. As you can see, the vehicle on the left continues to move. The standard says that the vehicle should be able to maintain its position on this slope, facing both downhill, forwards, and backwards for 5 minutes without failing, and clearly the one on the left has not passed that test.
This is a cyclic testing lab. What we do here is we simulate the lifetime of use for cribs, for example, by running them through our crib shaker test, crib impactor test, side rail impact test, and then our slat test. And combined, these simulate a lifetime of use by a typical child out in the field.
This is the durable children's product testing area. We have the toy lab also over here, and what I'm going to be showing you guys today is the walker stair test. And what we're looking for are skid pads on the underside of the baby walker. Right now there's only casters on it. There should be rubber pads here so that when it falls over the stairs it stops short and doesn't tumble. The velocity of the 8-pound weight falling will create a set speed that we know a child can achieve. So obviously if it had the skid pads on it, it would have stopped short and it wouldn't have gone over the edge. This is the impact testing area, and what we're looking for here are any small parts or sharp edges that break off during the impacting. Depending on how old the child is, depends on how high we'll drop it from. Pretty simple test, but we're going to take it down so that it breaks one of the laser beams, but not both. That would be too far. That'd be outside the regulation. And again, if we get any small parts or sharp edges out of that, that's a failure.
You are in the bike helmet impact lab, and here we test helmets. This particular test raises up the helmet so that it reaches an impact velocity of approximately 11 to 14 miles an hour, and that is roughly comparable to a lot of bicycle helmet impacts and injuries. This is an important test because it ensures that bike helmets comply with the federal regulations. And in this particular example, like I've got in my hand, on the outside, looks very, very similar to anything else that you would see in the marketplace, and yet it broke. So that's why we test.
This is the CPSC Flammability Laboratory. We have the capability of evaluating mattresses, mattress pads, and children's sleepwear to the federal regulations. In this new lab space, we have a special burn room that is capable of handling larger scale fires. The room is instrumented with a special hood that can measure the heat release from the fire below. This is an example of the children's sleepwear test. The sample is hung in the test cabinet. Small flame is held for 3 seconds to the bottom edge. It's a vertical ignition. Once the specimen is ignited, it's allowed to burn until completion. As you can see from this example, large flames burning vigorously. It would not give a child the opportunity to react very quickly, and therefore this sample fails the test.
We're here in the chemistry lab of the CPSC, and we test children's products for lead in paint and plastics. We're testing using X-ray fluorescence, and that's something we do with the same instruments at our ports of entry. We also have another special kind of XRF called an HD XRF, which we can use to measure lead in paint down to 0.009%, which is the regulatory limit.
One of the other things we do in the chemistry lab is test for phthalates. We have a brand new instrument called the direct analysis in real-time mass spectrometer. It's a real advantage for testing for phthalates. Traditional testing requires a lot of sample preparation. We have to cut the sample up, dissolve it in some harsh organic solvents. We run instruments, their run times can be anywhere from 20 minutes to a half hour. But this direct analysis instrument allows us to put the sample in without any sample preparation. We can just take a quick glass tube, rub it on top of the sample to get some of the material off, and put it into the instrument. Hot gas runs over the sample and brings it into the instrument, and the instrument actually measures the mass of the different molecules that enter. We can look at the printout, get an idea of what molecules are in there, and then we get a quick yes or no answer: are there phthalates?
The CPSC stands for safety, and this state-of-the-art facility is a testament to our renewed commitment in keeping families safe.
Just one more rinse and you are all done. I wonder who that could be. I'll be right back, sweetie.
Children can drown quickly and silently. About 2/3 of in-home drownings occur in the bathtub.
Oh no! Call 911!
Turning your back for a moment could mean missing out on a lifetime of moments. It only takes a few seconds for a child to drown. Never leave young children alone in the bathtub or around a container of water. Visit cpsc.gov to learn how to prevent in-home drowning.
While pools are an obvious risk, parents shouldn't let their guard down around other hazards such as bathtubs, buckets, toilets, and other water-bearing containers. A child can drown very quickly in only inches of water. Bathtubs account for the highest percentage of in-home drowning deaths. The majority of bathtub deaths and accidents occur when the caregiver is not present. Always keep a baby at arm's reach. Never leave a child alone in a bathtub, not to answer a phone or door, or to retrieve a towel or other item. If you must leave the room, take the child with you. Never leave an older sibling to watch a younger one bathing or playing near water. A baby bath seat, no matter how seemingly secure, is not a substitute for supervision. A bath seat is a bathing aid, not a safety device. Even when a child is in a bath seat, you should always be in arm's reach of the child. Buckets and pails, found in every home, are a real hidden hazard. Never leave a bucket containing even a small amount of liquid unattended. When finished using the bucket, always empty it immediately. Young children are drawn to man-made landscape ponds, which are becoming more and more popular in home gardens. These features often have no barriers to prevent access by young children. Children can fall head-first into a toilet. Keep the toilet lid down to prevent access to the water. Consider using a toilet lock to stop young children from opening the lids. Consider placing a latch on the bathroom door out of reach of young children. Remember, little children can drown in only inches of water. Don't leave children alone around bathtubs, toilets, buckets, and other water-bearing containers in the home.
Whether it's careful candle placement or checking the warning label on holiday lights, simple safety tips can go a long way in preventing fires and injuries this year. When purchasing an artificial tree, do look for the label for fire resistant. Although this label does not mean the tree won't catch fire, it does indicate the tree is more resistant to burning. When purchasing a live tree, do check for freshness. A fresh tree is green, needles are hard to pull off from branches, and do not break when bent between your fingers. The bottom of a fresh tree is sticky with resin. When tapped on the ground, the tree should not lose many needles. When setting up a tree at a home, do place it away from fireplaces, vents, and radiators. Because heated rooms dry out live trees rapidly, be sure to monitor water levels and keep the stand filled with water. Indoors or outside, do use only lights that have been tested for safety by a nationally recognized testing laboratory, such as UL or ETL. Use only newer lights that have thicker wiring and safety fuses to prevent the wires from overheating. Check each set of lights, new or old, for broken or cracked sockets, frayed or bare wires, or loose connections. Throw out damaged sets. When using lights outdoors, do check labels to be sure that they have been certified for outdoor use and only plug them into a ground fault circuit interrupter. Keep burning candles within sight. Extinguish all candles before you go to bed, leave the room, or leave the house. Keep lighted candles away from items that can catch fire and burn easily, such as trees, other evergreens, decorations, curtains, and furniture.
Keep your holidays as safe as they can be. For more tips, visit cpsc.gov.
I decided I wanted to launch a mortar shell style firework that you might buy in a fireworks stand. I put the mortar shell actually inside the tube, made sure that it was all the way at the bottom. I lit the fuse, and then I decided to hold the fireworks above my head. The mortar shell then exploded inside of the tube instead of launching out of the tube. When the mortar shell exploded, I have a scar in this hand and I have a scar here, and literally what happened is my hands folded over backwards. So off of my left hand, I lost my pinky, I lost my ring finger, I lost the tip of my middle finger, and I lost my thumb. On my right hand, I lost my index finger, the tip of my middle finger, and severely damaged the tendons in my thumb. The doctors at the time didn't think that they were going to be able to save my thumb, that they thought that most likely they would have to amputate it, but they were able to save it, thankfully. These were legally purchased fireworks. I had used them in the past, and I'd had plenty of experience with them for years and years of shooting them, and had never had anything go wrong until this one exploded inside the tube, detonated in my hands. The biggest thing I would like to get across to everybody is that things don't always go as we plan. Fireworks, mortar shells are very dangerous. People die using them, people get hurt using them, people lose fingers using them, and it changes your life forever. So I would say leave the mortar shells to the pros and leave them on the ground if you're going to use them.
Uphill, downhill, through the mud, and through the trees. ATVs can take you on an adventure. But before you do anything on an ATV, take knowledge to the extreme. Know the basics. Take a training course. Wear a helmet. Don't ride on paved roads. And don't ride tandem. That's knowledge you can take anywhere an ATV takes you. For more information, log on today to atvsafety.gov.
You ready to go home?
Yeah, sure.
All right.
Here she comes. She sure looks ready to take on this ride.
That's right, Megan. She's been riding at the top of her game lately.
I love how she puts away the headphones.
Yeah, she's not about to be distracted.
And look at that poise. She slows down at intersections, making sure the path is clear.
Nice, smooth braking. Here's that bump. Could be trouble. Will she lean back and use that same smooth braking technique?
Indeed she does.
Look at that expert parking. And that's how a champion gets it done, folks.
When they were younger, my kids referred to us as the toy police, which we affectionately call ourselves as well. I think a consumer assumes when they walk into a store that the products they're looking at are safe, and that's where we come in.
Anything that could potentially harm consumers, my job is to stop it here.
We're co-located with CBP, Customs and Border Protection, at the ports. We make sure these products are safe and are not going to harm children, loved ones, or their home.
We review incoming merchandise, based on what's listed on the manifest and the shipping lines. We decide what shipment might be the highest risk and what we really want to take a look at. We bring the merchandise into a warehouse. They strip out the whole big container, and then we go through that merchandise and we open up the boxes, we see what's inside.
Now, if that's toys and children's products, we're screening for lead, we're screening for small parts, we're screening for certain labeling requirements.
And then we try to decide if it's something that we need to test further, if it's something that might be hazardous, if it's something that we cover, and we think may look like it poses a little bit of a hazard, then we'll go ahead and we'll do some screening and some testing here at the port.
Unfortunately, when we're screening products, we still see lead. That's lead in paint, lead in content.
When you go out and you buy a toy for your child, for the most part, you're thinking that this is something that is going to be fun and that your child is going to like, and you shouldn't have to worry that it's going to harm them.
It's easy to be passionate about our job because we keep people safe.
We all go to the store. We all have, families. My kids play with toys all the time.
Most of us are consumers. Most of us are parents. It's a rewarding job in that you know for a fact that you are preventing injuries and you're preventing house fires and kids from getting hurt.
We want to make sure that you're not going somewhere paying your good hard-earned money and then you bring home a junk product that's going to end up hurting you and your family.
We're a very small agency with a large task, so we want to protect consumers from possible risks of injury or death. I definitely feel good about what I do on a daily basis.
What I enjoy most about my job is that I make sure I make a difference in consumer safety.
It's always a great feeling knowing that, one kid was saved today somehow because of what we did. So that is just an amazing feeling.
So I evaluate and review all the inspections, all of the testing data, and we do determinations whether they comply with our regulations or not.
I conduct on-site interviews with consumers who may have submitted a complaint to CPSC.
As a import surveillance compliance investigator, we do examinations of the products when they come in.
Here at CPSC, my job is to test ATVs. We assure that every ATV here meets the federal regulation.
But I think ultimately you feel part of the team from day one.
Yeah, you're not just another number at CPSC.
We have a diverse team. Some of us are prior military, like myself.
Most of my coworkers are like family. We talk about, how's life, how's the kids, and that translates into work.
I work with epidemiologists, I work with other engineers, I work with economists, I work with lawyers. We bond very well, and it's a great team environment here at CPSC.
As a federal employee, you get many great benefits that are not found in the private sector. The flexibility for training and professional development, great work-life balance.
In terms of growth, there's plenty of opportunities, plenty of avenues based on your interests, which is another key feature.
We have to invest in our people to sort of keep their edge and be able to keep on top of a marketplace that's exploding. So that's a significant focus for us.
The advantage at a small agency is it's very intimate, it's very family-like. It just makes it a more interesting place to work.
I like at CPSC that there's a variety of work we do, and so every day there's something new that I work on, so I know I'll have long-term effects.
You have every opportunity to succeed at CPSC, you just do, and that's what I would tell them.
So I think what makes CPSC a great place to work is a combination of the people, great ability to work together, but also the mission. We're here to keep people safe.
I've been here 21 years, and I have to say it hasn't been a day that I actually didn't want to go to work.
Welcome back. I hope everyone had an enjoyable lunch. For those of you just joining us, I am Nevin Taylor, the Chief Technologist at CPSC. In this role, my primary goal is to look at AI and ML in consumer products and establish a test and evaluation process to screen, assess, analyze, and ascertain if these technologies contribute to hazards that create safety concerns. To that end, the assessment panel will explore how to best monitor and measure the potential risk AI and ML presents to consumer products and will be moderated by Joanna Matheson. Joanna?
Thank you, Nevin. Good afternoon and good morning and good evening, depending on where you're joining us from. I am Joanna Matheson, and I am a toxicologist in the Health Sciences Directorate here at CPSC, and my work has a focus on nanotechnology. This next panel will explore the contributing factors of AI and ML to product hazardization and as that contributes to safety concerns. Our first speaker is Deborah Prince, the Standards Program Manager at Underwriters Laboratories, located in Research Triangle Park, North Carolina. She has over 25 years of experience in that role and has managed not only specific requirements regarding consumer products, but also groups of standards and their interrelationships. Thank you, Deb, for joining us today.
All right, so I pulled a silly and was unmuted also. Can you load my slides, please? And while they're doing that, I want to thank the Commission for the opportunity to speak today. I'm going to talk about AI and product risks to consider. Next slide, please. So let's start with what I'm calling traditional safety standards. Standards that are used to address safety of a stovetop range, pressure cooker, washer, dryer, refrigerators. We all know what a traditional product looks like. Next slide. So these may have, excuse me, construction requirements, such as frame enclosures, accessibility to live parts, environmental concerns like corrosion, electrical concerns such as grounding, insulation, protection against injury to persons such as sharp edge tests, strength of the door, surface temperatures, performance. So that would be a temperature test, an end normal operation test, endurance test. There'll be manufacturing and production testing. There'll be marking and instructions such as do not operate unattended, as well as how to operate the product safely. If the product allows remote operation, this adds risk to consider. Cybersecurity. A product cannot be hacked to override, say, the maximum temperature settings. You need to look at electromagnetic capabilities, that the product doesn't interfere with other devices in the vicinity, and interoperability. Functional safety must tie back to the product and not the smart interface. You have to remember that these products do not have to be used remotely, it's just an option. Remote operation cannot disable any protective control or function. You need to also consider over-the-air updates. Is the update complete? Did they get interrupted? Things like that. Next slide, please. As has been stated numerous times today, consumer products are incorporating machine learning and artificial intelligence. Next slide, please. So what are some of the reasons that a consumer product might add artificial intelligence to their product or machine learning? Well, artificial intelligence can offer significant sustainability, safety, and ease of use benefits to the consumer. AI can help reduce energy consumption. It can alert owners of malfunctions such as leaks or pending maintenance needs. And it can provide an easier way to manage routine tasks. Next slide, please. And go ahead to the next one, please. As consumer products become more smart, does the risk to the consumer change? Standards are evolving to consider and address these emerging categories of risk. Standards must address at a product level, is the product still functioning as intended? Safety related, is AI or ML relied upon for safety of the product? Does AI or ML potentially interfere with the safety of the product or change the hazard profile? Are the algorithms reproducible and dependable? Is it updated? Was that update without corruption? Was the updated safety related? If so, was that an automatic update or was it up to the user? And if it was up to the user, what happens when the user doesn't do that safety update? So next slide, please. So again, with AI and ML, validation testing of the product and the algorithm becomes important in the assessment of the product. And we've heard that this morning also. So does the product perform as expected? Is the product performance repeatable? How can you determine if the product continues to perform in a safe way as it continues to learn? Conformity assessment as it exists today is based on a product and how it behaves as it leaves the manufacturer. ML and AI products change over time in ways that the current conformity assessment scheme hasn't even considered. So that is a challenge for sure. All right, next slide, please. So algorithms will need to be evaluated, but to what? Let's consider maybe they should be evaluated or they should be evaluated for repeatability. So what could that entail? An assessment could include detailed scoping of what that application that the algorithm is supposed to be doing, description of the data set used, appropriateness of the performance matrix, controls implemented in deployment, tracking of that algorithm performance in production. Products may perform differently when subjected to intentional or accidental misuse, or exhibit unexpected failure modes during deployment, or be adversely affected by software updates or lack of software updates, either by mistakes or the individual did not do the update. Next slide, please. Structured data is important. Structured data is used for training the product and defining the operational design domain in which the product is expected to operate reliably. Safe products will depend on defining an exhaustive list of overlapping conditions a product might encounter. What if that product is used outside of that domain? A robot's ODD may be for inside. What happens if a child is using this robot and takes it outside? Are there consequences of that use case and using it outside of the ODD? Another example of wrong data used is if the product is intended for use by a child. All the training data that was used was for an adult. Imagine a robot that was trained using the behavior of an adult, not a child. This has the potential for harm. We all know that children behave more impulsively and without a bank of knowledge of risk that can happen that adults have. This could be a big concern. Next slide, please. So defining and assessing risk, that's a big question. How do we do it? You know, there's going to have to be a unique approach to handle AI and ML risk assessments, or a completely different risk profile. Again, is the AI or ML part of the safety mitigation? Can AI and ML cause a safety concern? You know, there's so many things that have to be looked at from a standards perspective and a risk perspective. Next slide. So autonomy and autonomous products rely on AI and ML, and their products are moving into these products are moving into the consumer product realm, or shortly will be, such as consumer or educational robots, autonomous four-wheelers. So UL, Underwriters Laboratories, has an existing standard to address these products. ANSI UL 4600 is a standard for safety for the evaluation of autonomous products. This standard has initially been focused on the autonomous vehicle, but could be used for a robot or a four-wheeler with just some requirements that are not being applicable. So next slide. UL 4600 requires a safety framework. A manufacturer tells a story about everything they've considered, the environment's abuse, all scenarios, all judgments. This leads the designer through a thought process required to consider the possible complications the system may encounter. Requires evidence that the system is sufficiently robust to mitigate foreseeable hazards, as well as have you considered unforeseeable hazards, right? Criteria of the standard falls into mandatory, required, highly recommended, or recommended. Mandatory requirements are just like they sound. You must comply. Required means you must do this unless it doesn't apply to your product. An example would be machine learning requirement. If your product doesn't use machine learning, you would just state that it doesn't apply and why. Highly recommended and recommended are not requirements, but things that you should consider to have a robust safety case. In addition, 4600 is unique in the fact that it provides prompts of have you considered and examples and known pitfalls. The standard is not prescriptive. It does not tell you specifically how to mitigate the risk, but requires you to document how you have considered all the risk and how you will mitigate those risks. Next, please. All right, Chapter 5 in the standard states that the safety case shall be constructed with an explanation in the forms of claims, supported by arguments and evidence that justifies the items are acceptably safe for a defined operational design domain. This covers the item's life cycle. So is it argumented sufficiently? So have you identified all the safety-related hazards and the risk in forms of arguments and supported claims? And I'll have an example later on. A claim. So this claim support system avoids hitting pedestrians. So your robot will not run into pedestrians. Argument, why is this true? You can detect and maneuver to avoid or stop when you can't maneuver. So is the evidence sufficiency? All arguments in the safety case need to be supported by evidence, and each argument is traceable to supported evidence. Examples can be a test plan, test results, experimental design methodologies, to name a few. So with the claim, your robot avoids hitting pedestrians. Your evidence supports arguments by tests, analysis, and maybe simulations. And then you have validity of that evidence. You identify criteria used to determine sufficiency of the evidence, and you argue that that evidence is sufficient to result in an acceptable safety case. Meaning, describe the manner in which is used to support or refute the validity of the argument and or claim, and argue that risk of confirmational bias has been mitigated. You have an acceptable risk that is demonstrated through the life cycle. You have life cycle monitoring employed to monitor the risk to the degree that the argument relies upon, as well as the opinions, assumptions, and potentially weak evidence. You have your safety culture, your reproducible elements, such as the role of safety staff in ensuring the safety role, the independence of the safety roles, and then you have the item scope. So safety-related functionality, safety-related components, safety-related properties. Next slide, please. So to illustrate how UL 4600's approach can be used with a consumer product, this is an example of what a portion of a robot safety case might look like. All right, so the safety case is not 100% aligned with the UL 4600, but it does show a logical goal structuring notation approach. A graphical representation of a robot safety argument that makes it possible to show complex relationships and dependencies that may be difficult to communicate in simple text. This framework is a structured argument supported by evidence to demonstrate a claim for why the robot is acceptably safe. No single piece of evidence captures the totality of safety. There are complex interactions and relationships between many elements that go into a robot. The top level claim or goal in the robot framework is that the robot is acceptably safe to operate in public spaces. Rest of the safety case is substantiating that top level goal. The top level safety goal is broken down through layers of intermediate arguments, contexts, and strategies. This approach enables the tracing of each safety argument through a broad concept down to specific, tangible evidence supporting that claim and subclaims. The evidence is used to support a claim can come in many forms, but two of the examples are product evidence and process evidence. The product evidence includes a deliverable such as the technical specifications, test plans, test results. Process-related evidence demonstrates that the product evidence was generated in a systematic manner with sufficient rigor, review, and independence. This evidence may include informal internal audit reports or confirming that an established process is followed. So again, if you look at this slide here, you've got all these different branches, right? It's operating near unaware human. How would you, that's a claim that you need to substantiate. The hazards are covered by functional safety. The non-movement based hazards are mitigated. All the hazards are identified. Right? How are you sure you have that? And then you have, it won't collide with the human under normal operation. It will park in a non-populated thoroughfare. It will provide warning when parking in that thoroughfare. It will not move if being ridden on by a passerby. That one, key, right? Children, robots, they're going to try to ride it if they can. Next slide, please. All right, UL 4600 also has guidance on safety of machine learning about the data acceptability and variations. The machine learning training and validation must ensure that the data also accurately reflects what's in the operational design domain. Like I said a few slides before, if something has not been tested or built around this domain and the product goes outside of that domain, you have to look at that and have ways to mitigate that. So the data is acceptable across the entire ODD. The training and testing data should be traceable to that ODD. The data collected from the ODD should be statistically valid. The safety-related aspects of the ODD are represented in that data. And low probability events have been appropriately risk mitigated, and the data has historical records of its origin. Next slide, please. UL 4600 also has guidance on safety of machine learning, the data integrity. This is again from Clause 8. Machine learning And testing must ensure that the data collection equipment has acceptable integrity, the data labels are accurate, that the pre-processing, storage, and retrieval of the data does not degrade the data integrity. The data integrity includes configuration and versions management. Any data or machine learning tools have acceptable integrity. Data quality is comparable across data collections, training, validation, and operation. Next slide. So what else? AI systems need to remain verifiably safe throughout its lifetime, even as it continues to learn and develop on its own. That is going to be a challenge. Provided some ways that you can address AI from a standards perspective, using a safety case. There are other standards that are being developed out there. I think the key with this is that these standards need to be nimble, they need to be flexible as we're learning, as well as the product's learning, as well as conformity assessment is changing. I think when you're looking at standards, sharing knowledge to help that product become safer is key. It's important. CPSC can help with that. NIST can help with that with their framework. I think standards should have a feedback loop where you're providing that feedback into that knowledge of the new products and how they affect the standard. And I think having examples in there or known pitfalls, especially when you're working with data sets or algorithms, I think that will help the community as a whole. Again, and I think having standards that are not prescriptive are key, because we can't stifle that innovation. So standards must be flexible. They need to be nimble as the technology evolves. So with that, thank you so much. And I appreciate your time today.
Thank you, Deb. The next presentation is from Travis Norton. He is the Director of Global Technical Service at Bureau Veritas. Travis leads and manages a technical consultation team that includes certification and testing of smart home, smart wearables, and connected consumer IoT devices. He is a member of the Open Connectivity Foundation and the ANSI Unmanned Aircraft Systems Standardization Collaborative, as well as a member of ASTM. He participates on committees F38 for Unmanned Aircraft Systems, F12 for Security Systems, D13.5 for Smart Textiles, and F15 for Consumer Products, including the new F15.75 Committee for Connected Consumer Devices. Thanks for speaking with us today, Travis.
Thank you so much. And thank you to CPSC, and I applaud the panelists so far today. There's been some really great content. It's actually caused me to think a little bit more broadly about the data and also the different mechanisms that AI and machine learning use. So I'm going to talk about a couple of topics, more in depth about the safety of connected products and the ASTM standard we've developed that deals specifically with connected products. But I would challenge you to think about how is what we've developed already as a safety guide for connected products, how is that applicable or not applicable to using an algorithm to make decisions, or pattern recognition that we see in AI and machine learning. So next slide, please. So first, I'll talk just a little bit about ASTM 3463. What was it that was happening, and how did we get to the actual draft of the standard and the final version? And as I said, as I go through this, I really want you to think about, would this be applicable to artificial intelligence, machine learning, as they become embedded with consumer products? And in particular, you look at the guide as a starting point for discussion. What revisions and changes would be needed? And as we start to think about how algorithms or pattern recognitions work, specifically, what would be different compared to just a generally connected product that might be getting a software update? So next slide. So a little bit of background in terms of what was driving this. There was a lot of editorials about connected product failures that were in the marketplace, where they were seeing all kinds of things from data privacy breaches, security issues, cybersecurity issues. There were not a lot, but some cases where consumer products were displaying what appeared to be hazardous conditions as a result of the connectivity. So, bottom left corner, smart oven turning on in the middle of the night after a software update was pushed out, or a thermostat turning people's, home heating systems off during the wintertime. That these things could result in a hazardous condition. And so some concern was being raised about the nature of what was being observed as these products are being rolled out, maybe the lack of ability for some of these manufacturers or software updates to understand those changes. And organizations like the CPSC, OECD, European Commission, and others started holding forums and discussions to look at these issues, to try to understand the severity of them, and to really pool experts from the industry to see what our thoughts were about how we could address these issues, what kind of mitigation strategies should be used, and I think helping to define where a company that's doing its due diligence to prevent these issues, what are they doing, and what are some of those best practices to be able to differentiate maybe a rogue company that's really doing nothing. Next slide. As a result of those forums by market enforcement, the testing, inspections, and certification group, which is what Bureau Veritas is part of. We do third-party compliance assessment along with UL and SGS and many others. We collectively, put aside our competitive differences and collaborated to come up with a set of principles that we felt as a starting point for discussion around connected product safety. And these included things like, if there is an existing rule, ban, or standard, that the connectivity of that product should not interfere with that. If a product has an existing safety standard, and Deborah was just talking about some of those, where the update to a software or the update to firmware or these types of things should not cause the product to suddenly become non-compliant with a safety standard. If the product has a safety function, like a smoke detector, a software update shouldn't disable it so that it's not functioning without alerting or notifying the consumer in some way. So we took a number of these different principles and looked at things like, what manufacturers and importers of these products should be doing, what testing labs and assessment companies like ourselves should be doing in terms of evaluating these products, and device libraries, and considering the range, what Deborah was talking about, the operational design domain, where you're thinking about not just, the specific intended use of the product with a particular controller, a particular phone, but the range of phones, the range of operating systems, the range of environments that are out there, and thinking about how do you take that and put that into a program, testing program, evaluation program, to be able to evaluate. So these principles were put together in response to market enforcement like CPSC asking these questions and really asking the industry to provide this input. Next slide. So one of the challenges then became these principles. What does it mean, right, at the product level or product category level? And as was mentioned, I'm on a number of these different committees. There's far more committees even that are listed here. I'm on the textiles, home security systems, unmanned aircraft, consumer products. But there's also ones out there on exoskeletons and robotics and things that are also going to be using AI and machine learning. In most cases are probably connected, to a network and are receiving updates. So the potential for consumer products across a very wide range to be then in scope for the guides we developed, and starting to think, well, does that apply, and what does that mean to a wearable? What does that mean to a home security system? What does that mean to, a drone that you can fly in your backyard? Next slide. So we took this to heart, this wide range of consumer products that are out there. And again, this is, I've highlighted the standard here, and I put in, AI/ML, just to remind you, the audience, to think about what I'm saying in the context of, does this make sense for an algorithm that's making decisions, or pattern recognition software, that's operating? It's one thing to say, okay, if any of these products, whether it be a toy or a smart TV or a wearable device, if they're using, AI or machine learning, and that algorithm is locked prior to deployment in the market, then it may be possible with a traditional compliance assessment scheme to say, okay, we've looked at this ODD, we've run it through the device library and made sure that it's compliant. Given that, and that it's locked prior to deployment, you can feel fairly confident that you've at least covered your base. It becomes a little more challenging when it's not locked and it's actually out in the wild, learning and adapting and evolving. The algorithm is updating itself and making better decisions. Pattern recognition is becoming more refined and more enhanced over time. Who's monitoring that? That's already out there. It's loose. And how would we then, from a compliance assessment, evaluate those products and continue to understand where those hazards exist? So this standard developed for connected products, tried to look at a very high level these principles that we came up with in the TIC industry. And I'll go through some of them, but I really want you to think about, how would we adapt and evolve these to go beyond just connected product and really think in terms of machine learning and AI. So think about this range of products in the context of what we're going to look at next. Next slide. So getting into some of the details, we were saying that, a connected product should never compromise the safety of the device. It should not introduce a hazard. For example, we had seen products where there was a safety mechanism that prevents a hazardous condition from occurring as the product is operating, and a software update was pushed to the device, the safety mechanism was disabled, and there was no longer any mitigating control of a hazardous condition occurring. So this is the kind of stuff that we're saying we want to make sure that as a guide or a principal that it's not doing those types of things. Also, we don't think it should disarm any safety control mechanisms that may be operating in the product. So don't create a hazard, don't turn off anything that might have been controlling or mitigating or stopping hazard at a very high level. Next slide. So then, kind of looking at what developers should be considering. I think Deborah pointed out some really great points from the UL 4600 about scoping of the algorithm, the controls and tracking, the ODD, thinking about the safety cases in particular, really getting into that mindset of risk assessment and not just the intended use, but the foreseeable use of the product, and thinking about the likelihood that a connectivity issue could impair. And Deborah mentioned some of those situations, like, if you power cycle a router, or you were to turn a device on and off, or your phone on and off, and it reacquires or reconnects to the connected device, does that in and of itself result in a hazardous condition? For example, the smoke detector during a power outage, when they turn back on, and are they enabled, are they turned back on? This type of thing. So these types of issues that we suggested that developers should consider, I think would ask sort of the wider audience and some of the experts that were speaking earlier to think about, do those principles still make sense when we're talking about an algorithm or pattern recognition software, what we refer to as AI or ML? The ability of that software to be updated to improve safety was something that we also wanted to highlight. It's not just negatives with these, that you might find that there's an issue with the product and you can make a tweak to the existing software and push out an update, which then may mitigate it. As opposed to a product recall, you might be able to just do a software update, which is really great, about connected products, and that it has those potentials. To keep that in mind as well. Next slide. We also thought that people who sell these products, that are responsible potentially for the liability of any consequences downstream, due to hazards occurring in the marketplace, lawsuits and product recalls, that they should be ensuring that these products, before they're put on the market, are going through some kind of safety assessment. And I think the safety case and life cycle assessments that Deborah was talking about is a really good place to start. I'll talk a little bit about risk assessments at the end of this, but just generally saying safety by design, if it's going to default into a safe mode, as I mentioned with a smoke detector, power goes off and comes back on, it should turn itself back on and go back into, detecting smoke. So it's ultimately about that these things will fail in a safe way. This is an inherent concept within consumer product safety design anyway. We're just saying that should also be true regardless of if the software update is interrupted, or if there's a power cycling or there's some event that causes a disruption to the code of software, that it defaults back to a safe mode in that state. The other thing would be, really in a connected product sense, testing that firmware or software update before you push it out. In the case of some of what we'd seen in a few slides ago, where a software update had caused a safety control mechanism to become disabled or caused a toaster oven to turn on in the middle of the night. These things can be preventable if you're able to push that software update maybe into a population of these under a controlled situation and observe how they respond and go, oh, there's a problem. Let's adjust that, and then let's now release it. As opposed to maybe testing it in a black box and only doing checking software, we think it's really important that software updates are tested at the product level and to see what the effect on the product is. It doesn't necessarily mean you have to go out and retest the entire product or that every clause of a safety standard is in scope, but think about what that software is controlling. And if it does control the power system, if it does control the heating element, if it does control a safety mitigation mechanism, then yeah, you probably want to make sure that whatever changes you're making to the code has no impact on that in a negative way. So again, as the audience, I would encourage you, does that make sense when we're talking about AI and machine learning? As a principle, probably yes, but and I think that you run into these two scenarios I mentioned earlier, where if the algorithm is locked prior to deployment, then you can do this and you can control this. What about algorithms that are in the wild, that are evolving and are learning as they go? Is there a potential that the algorithm could learn something, or a pattern recognition system develops an insight based on what's happening in the field that could then result in a hazardous condition? Thankfully, we haven't seen much evidence of this yet, but this is the kind of stuff we proactively want to anticipate, not just in connected products, but in machine learning and AI. Next slide. As I mentioned, testing of these things is important, not just in a black box scenario, but thinking about the impact of that. In the standard, we went to some length to talk about evaluating it under the intended and reasonably foreseeable use conditions. And Deborah was echoing that as well when she was talking about the safety case and thinking about the life cycle of the product. We think this is really important, to consider not just what are you telling consumers how they should use the product, but what do you think is likely? Throw some toddlers in the mix, throw some teenagers in the mix. What kinds of things can happen? What kinds of environments and conditions might occur? And just based on what we see happening in our own homes and in our communities, can we then come up with some of these hazard scenarios and use cases to determine whether there would be a potential risk to something that we're doing at a software level or AI or machine learning level. Next slide. We also felt it was important to address cybersecurity. I know CPSC would consider, I think, a cybersecurity attack to be a criminal activity and refer you to the Department of Justice. It's not necessarily a product defect at this point, but it's something that as a wider community in the industry, we felt like it was important in this safety standard to talk about the fact that these devices should have some security. Security is proportional to risk. And when you look at the potential impact that risk could have, thinking about how you want to secure those devices and the severity to which you want to put a user through in terms of authentications, passwords, biometric verifications and so forth that could be used to make sure that the right people that should have authorization to control the product or operate the product have that. And when you think about vulnerable populations or even children and so forth, authentication becomes fairly important. I know my 2-year-old picks up a number of devices and has no idea what she's doing and just starts pressing buttons. And some combination of those, if it could result in a hazardous condition, is something you wouldn't want the device to operate. Thankfully, my phone has a code and you can't get into it and do anything harmful if you don't know the code. And that's what we were saying here, is that some kind of security mitigation may be necessary if the device is capable of subsequently causing a hazardous condition. So in the ASTM standard F3463, we don't necessarily get into the nuts and bolts of what we're not prescribing the cybersecurity standard, but we provide a list of references that the industry can then go and take a look at. There's a number of really great standards out there and certifications available on cybersecurity. Next slide. So I mentioned risk assessment a couple of times, and I just want to make sure that for this audience that everybody's somewhat grounded in. And I also wanted to share a couple of screen snapshots from a tool that we use at BV when we're looking at consumer product hazardization, a term that CPSC coined, and just thinking a little bit about risk assessment. I've got a couple of these I just want to put up. So the next slide. If we were looking at the AI risk management framework, which the keynote speaker today was going through, and in fact, the last few days, they've had a great workshop going into the details of the risk management framework, you will see the word safety show up quite a bit. And I'm glad to see that that's embedded. It's not just about data privacy or interoperability or bias. I think those are also important characteristics for trustworthiness of AI. But in every one of the documents I've looked at where they're talking about characteristics that make it a safe or acceptable or trustworthy, depending upon the terms they're using, you always see this word safety embedded in it. So the AI and machine learning and ensuring that safety is taken into consideration is a key aspect of deployment of these devices, in particular with consumer products where there's such a wide range of conditions and consumers and foreseeable uses that can happen. So I just wanted to call out a little shout out for NIST and the work they're doing. I think there's a great risk management framework they put together. And there's been some great discussions in the last couple of days. And I'm anticipating once that's out there that any organization that is considering to use AI or machine learning in consumer products should first take a look at that risk management framework, then go through the details of it, see what applies to you and apply those aspects to it so that you are covering privacy and bias and these other things. But when we talk about safety, we'll go to the next slide and really think about how that consumer product is introducing the potential for hazardization. You know, we look at risk assessment in a very simplified way. You can think of it in terms of these kind of 4 key variables. Arguably, there's the more detailed risk models will include more variables, and it's you get into more statistical probabilities. But just for the sake of simplicity and clarity, these 4 variables are key and can be used very quickly, I think, to go through a number of those safety case issues that Deborah was talking about, or what I might consider hazard scenarios. So first being, what is the maximum potential injury associated with that product? You know, when you think about if it controls a heating element, could it cause a fire? Could that lead to death? Does it have a moving part, which could lead to, you know, a laceration or pinching or shearing of a finger? So think about the product in terms of what is under the control of the software and or in this case, AI and machine learning, and what is the worst case that could happen, you know, in terms of a foreseeable condition. So what is that maximum potential injury that's out there? The next would be to think about the probability of that hazard occurrence. And this is a series of things saying, well, you know, this has to happen, and then this has to happen, and then this has to happen. And as you add more of those, this, and then this, and then this, you know, the probability goes down. But as you start thinking about all the different things that could happen, you may have a number of different scenarios. So the probability might be relatively small for any given scenario, but there may be a number of scenarios that you need to consider. And collectively, as you look at that, you know, then that probability of a hazard occurring may be, you know, worth considering what mitigation is necessary. So what is the maximum potential injury? What is the probability of that hazard occurring? The next one is hazard recognition. You know, and this is dealing with, you know, is the consumer aware of the fact that there might be a hazard with the consumer product? You know, if you had something like a knife in your hands, you know it has a sharp edge, it has a point on it. As an adult, you're aware that there's a hazard present. On the other hand, if you're sitting in a chair and the legs suddenly collapsed on you, you might not have expected that. You might not have anticipated it if there was no evidence of bending or cracking or sound prior to it breaking. You wouldn't be able to recognize it. So when we think about consumer products that are using connectivity or AI or machine learning, this is another aspect, is if hazardization is possible and there is a potential for injury, what is the likelihood that a consumer would be aware that such a hazard does exist with the product and be able to either instinctively or cognitively recognize that there's a hazard with the product and you know, protect themselves during normal use or foreseeable use conditions. And the last one being availability. You know, when you think about availability of the product, there's a couple of things. You know, one is, you know, if we're talking about you know, the sharp edge on a picture frame, you know, the availability of that is pretty low. You know, you're only really hanging it rarely. You might only hang it once, right? You're going to pull it out, maybe put it up on the wall. There's a point where you're putting the photo in and out where you're exposed to it, but the rest of the time it's safe and up on the wall, as compared to something like a toaster, where you might be using it every single day. So there's that aspect of availability. The other aspect of availability is how widespread is it in the marketplace. You know, there are some products that may be designed and targeted for specific audiences, and then there are products that you know, they're in every retail store down the street, everywhere across the country. So you want to think about it in both of those contexts. So these 4 variables applied to risk assessment, next slide, can be used together to try to understand the impact for a given hazard scenario. And so when you look at the maximum potential injury and you select, you know, anywhere from death to a critical injury to a serious cut to a moderate or minor cut, when you think about probability of the hazard occurring from remote to unlikely, possible, probable, almost inevitable, hazard recognition by the consumer, you know, in terms of their ability to know there's a hazard with that product, it's highly improbable. There's no way they would know, or pretty sure they would know there's a risk with it. And then that availability, how much exposure does that product get during its normal use in a consumer environment? How widespread is this in the market? And that becomes kind of a multiplying factor on these. So specific to artificial intelligence, you know, is if there was something in the application of the knowledge, you know, the way the algorithm works, it's not locked, deployed, it's learning in the wild, it gets some new update to its algorithm, either by a software push or based on what it's learning in its environment, and it reaches a point where hazardization occurs, then you want to consider that as a scenario and select the appropriate parameters. Risk assessments are generally best done with a group. You get a diverse team together, and you have people who are familiar with the product and its potential and what it does, someone who maybe thinks about the consumer and their activities and what's possible, someone who's familiar with previous incidents, you know, that have occurred with similar items. And that team is then discussing and selecting these parameters. And you may end up doing, you know, 100 or more of these scenarios and looking at a number of them. And if they turn out to be, you know, moderate or high risk issues, then what is the mitigation that you're doing? How do you lock that down in terms of software? How do you teach the algorithm, you know, not to go above a certain parameter because that's a hazardous condition? So thinking about how to do that in this scenarios is what I would encourage others to do. Next slide. The same can be said for pattern identification, where, you know, it's, you know, there was a great example earlier about recognizing a wolf from a dog. And, you know, I was thinking about, you know, what if you had like a cat door to the back house and it recognizes my cat, lets the cat in, but now a raccoon walks up, would it let the raccoon in? You know, and you think about pattern recognition operating in these products, and is it possible that it might somehow learn something and then operate in a way that creates a hazardous condition? So again, risk assessment rules being applied. What's the maximum potential injury if that happened? What's the probability of that hazard occurring? What's the likelihood that a consumer would be aware that that's happening or that risk exists? And how widespread is the availability or use of that? And so as you go through this, I hope what's emerging is that an understanding that the principles of risk assessment, the principles that we've developed for connected products, probably have a lot of direct application for artificial intelligence and machine learning. But there are a number of things that we as a community need to discuss. I don't think we can simply take the current ASTM standard and say this also applies to AI. I think that there's some great points been raised earlier today. One of them, like about the law of requisite variety, and whether or not that has an impact, you know, not just in terms of efficiency, but in terms of its ability to understand either in creating or mitigating hazards. You know, I think there's been some really great content and really great discussion that's been happening here today with the other panelists and the presenters. And I know that a lot of you in the audience have a lot of thoughts about this as well. So I would encourage you to think about these concepts, these safety principles for connected products, these risk assessment methodologies that have been in place for years, and how do we adapt them or revise them so that they are appropriate for artificial intelligence and machine learning. And with that, I yield back the remainder of my time.
Thank you, Travis. We have had some amazing presentations today, and I want to thank both Deb and Travis for what they have just provided us. And I think this is a great segue. We're going to have a 10-minute break right now, and this will be followed by a Q&A panel session. So I hope you stay on with us. I hope you submit comments and questions. I think this is going to be a great session that kind of pulls all of this together. So thank you, and we will start the 10-minute break now.
Congratulations! Whether you just had a baby, expecting a new baby, or taking care of a young infant, it's important to create a safe sleep environment for your baby. Hi, I'm Nikki Fleming, spokesperson with the U.S. Consumer Product Safety Commission. Today, I'd like to take a few moments to show you how to create a safe sleep environment for your baby. The safest place for your baby to sleep is in a safe crib, bassinet, or play yard. These items should never be placed near a window as they create a serious fall hazard and a risk of strangulation on window blind cords. Additionally, please remember these safe sleep tips. To reduce the risk of SIDS and suffocation, place your baby to sleep on his or her back. Do not place your infant to sleep on their side because this is an unstable position and the infant will tend to flip onto their stomach. This is an important recommendation from the Consumer Product Safety Commission and the American Academy of Pediatrics. Never place your baby to sleep on top of pillows or comforters. Remove these items from the crib. In fact, the vast majority of deaths associated with an unsafe sleep setting are caused by a combination of using extra bedding and placing a baby to sleep on his or her stomach. Make sure the crib has no loose or missing parts or slats. Cribs with broken hardware or even a missing screw can have their side rail become disengaged, allowing your baby to get caught between the crib mattress and side rail. Only repair a crib with parts provided by the manufacturer. Makeshift repairs can create new deadly hazards. The mattress should be firm with a tight fit on all four sides and no gaps or spaces. If you can fit more than 2 fingers between the mattress and the crib side, your crib is unsafe. Keep monitor and other cords out of your child's reach, as these cords can pose a strangulation hazard. Lower the mattress as soon as your child can push up on his or her hands and knees to prevent climbing out of the crib. Visit cpsc.gov or call the CPSC hotline to check if the crib model has been recalled. So, when selecting a crib, make sure it has not been recalled. When using the crib, regularly check to be sure all parts are secure. Don't put extra bedding or stuffed toys in the crib with an infant, and always put your baby on their back to sleep. To stay informed on the latest safety information and to receive free recall alerts, visit cpsc.gov, keepingbabiessafe.org, and aap.org. We would also like to hear from you. If you have any concerns about a product that could pose a danger to an infant or child, contact CPSC at 800-638-2772. Now we hope you and your baby can have both a good night's sleep and a safe sleep. Sweet dreams.
What is a drop side?
A drop side is a movable side of the crib that gives mom, dad, grandma, or any caregiver easier access to the inside of a crib. A traditional drop side slides up and down.
Are all drop side cribs bad?
Not necessarily. CPSC only hears about cribs with problems, not the ones that are fine. On the whole, a drop side crib has a tendency to be less structurally sound than an identical fixed-sided crib, and thus it is more susceptible to problems from use, being moved, storage, and assembly.
How can I tell whether my crib is safe for my baby?
Every time you change the sheets, check that all visible hardware, every bolt, screw, track, and clamp is securely in place. Make sure the drop side is on its track and functions well. With the mattress out of the crib, wiggle all the cribs to see how tight all the joints are. If the crib remains wobbly after tightening all hardware, look for loose wood-to-wood joints that may be causing the problem. Stop using the crib if loose wood-to-wood joints are found or if you cannot fully tighten any screw. Also, if one side of your crib is loose, do not push that loose side against the wall and continue to use the crib. The wall, along with a loose side, can create a space in which a child can get caught and smother.
What are immobilizers? Should I use one?
Immobilizers are protective devices that stop drop sides from moving up, down, and outward. If your manufacturer makes an immobilizer specifically for your crib, CPSC staff recommends that you get one and install it on your crib. Only use immobilizers on cribs that don't have missing or broken hardware. These devices protect your crib's hardware and limit movement so that a child can't get stuck between the drop side and the rest of the crib.
Can I just fix my crib myself?
Do not try to fix your crib. Do-it-yourself crib repair can be very dangerous and the results can be deadly. Infants and toddlers have died in crib with makeshift repairs. Untested screws can loosen and all kinds of tape, wire, and zip ties stretch, no matter how tight they may be at first.
My crib has a drop side, but I don't use my drop side. Do I still need to check my crib?
Yes, you should always do regular checks on your crib to make sure the components are tight and are not broken. Parts can still break and become loose even if the drop side is not used.
My crib has broken or missing pieces. Now what?
Stop using the crib and contact the manufacturer and report the problem to the CPSC.
Stop using my crib? Where do I put my baby to sleep?
If your baby is less than 6 months old and is not yet able to push up on their hands and knees, you can put your baby in a bassinet. If your child is older, you can use a play yard. If you believe your child is too big or able to climb out of a play yard, use a mattress on the floor or a toddler bed.
The safest place for baby is in a crib that meets current standards. Beginning June 28, 2011, all cribs sold must meet new federal requirements for overall crib safety. These new requirements prohibit the manufacture or sale of traditional drop-side cribs, improve slat strength, make hardware stronger, require tougher testing, and improve mattress support durability. America now has the strongest crib safety standards in the world. CPSC has recalled over 11 million cribs since 2007. CPSC has also received reports of 32 infant deaths associated with detached drop-side cribs. Our goal is to prevent these tragedies from ever happening again. Contact the crib manufacturer to see if your crib complies with the new federal standard. For more information on crib safety and the most up-to-date information on creating a safe sleep environment for your baby, visit us at cpsc.gov/cribs.
Wow, what a fantastic forum. Each of the presenters have given us so much to think about as they have spoken on the complexities of testing and evaluating AI and ML. Now we have an opportunity to address some of the questions as we transition to our Q&A panel. As a reminder, this forum will be recorded and potentially made available to the public. We are grateful to have our panelists and previous presenters for the Q&A panel. I'd first like to thank these amazing people for their presentations today. This panel will be a little different than the previous panels in that we will not have presentations, but rather engage in a guided discussion focused on test and evaluation of AI and ML as it pertains to consumer safety. We have a number of questions for our panelists, but also welcome and encourage audience participation. If you'd like to send a question, please do so to my email listed in the federal notice and your registration for this event. With that, let's begin our Q&A panel. Panelists? Outstanding. So I'd first like to start off with the first panel on the components, and I had a few questions that have come in for them. And anybody else who'd like to add to that? Question to you would be, how do you screen a product for AI and ML components? Mark, did you want to field that one, please?
Sure, I can give it a start. Well, obviously, there is an element of both the physical device for whatever that product or device is designed to do, and the form factor that it's in. And then, as some of the speakers alluded to, whether that device can sense and, let's say, respond. And so if indeed we have this sort of binary decision scheme where here's a device, that device has an element of sensing and responding, then we can ask the question, what are the means by which the sensing and responding is occurring? And therefore, the next logical question is, what are those controls? And then finally, what are the outputs? And so if the sensing and the decisioning is based on a mathematical algorithm, of course, we can look at the integrity of that algorithm with test data. We can look at the integrity of that algorithm with what results do we expect. But of course, in that simple sort of binary situation, we can very quickly get into some serious complexity as we have more and more sensing modalities and more response modalities. And so to that end, as I mentioned in my presentation, we also need to very simply look at how many controls there are around how many sensing modalities. So in the beginning, it's kind of almost arithmetical. Are there these components? If there are, what mathematic capabilities are there to both sense and react? And then how many of those are there? And are there enough systems to oversee and interact with those modalities vis-a-vis how many there are in the product? So, to me at first, it's really an accounting about the device, about the mathematics involved, about the sense and response capabilities. Once we sort of assess that, then we, I think, have a higher level of understanding the problem to say, well, what are the possible faults? What are the risks of those faults, and so on? And I'm sure many of the panelists here can speak to that in more detail than I can. But I would start with just that basic accounting. But that accounting involves the mathematics and the sort of the universe that the mathematics inhibits, rather not inhibits, but lives in. Does that make sense? I hope it does.
It totally does. I really appreciate that answer. And one of the things that, as we've talked about, is the quality of the output is only as good as the quality of the input. And we know that the input is data, and without data, you're not going to be doing AI or ML. So, I mean, you gave a fantastic presentation on data and helped us understand that, it's not always as simple as it might appear, both in its pedigree from where it comes from and how it evolves, its provenance over time. So can you maybe give us a little more insights of how do you measure and monitor the quality of that data?
Well, as I described, I try to move towards a very complex situation. That is, taking sort of content, unstructured content, if you will, in the wild. So anybody saying anything about anything. And we believed, both the team I was working with and certainly the work I did with the regulators, the FDA, that there was value there. And to your point, Nevin, that value could only be extracted if we had the confidence that we could believe that information, and more importantly, that decisions would be made that potentially could affect life and death, right? We don't want to remove a drug from the market because we had spurious data that said these people made a claim that it hurt them, because that drug is providing value. Products are the same way. You don't want to simply remove a product from the market because that product provides value. So the confidence is critical. And the way we addressed that was to essentially apply a set of mathematics algorithms that acted as sort of filters for what we considered not useful versus useful. Now, I'm going to sum up here because I'm actually introducing a paradox. And that paradox is that we may very well need ML and AI to evaluate ML and AI. So that paradox is, we're going to need to break that paradox, right? How do we use technology to evaluate technology so that we have the confidence to make decisions that are affecting the safety and well-being of people? And you know, I don't mean to be sort of in a dog chasing its tail, but I really think that's the path forward.
That's a really great comment, and Deb covered that as far as the necessity for consistency. And given the reliability of AI and ML in its consistent approach, it helps you get some, you know, an interesting perspective. I want to go ahead and talk about kind of a little more on what you talked about on the confidence level. And Mike did a fantastic job in his briefing, talking about, you know, the connectivity piece and the necessity for it to be reliable. And then of course there's a resilience piece as well. Mike, did you want to speak more to that? Because when we look at that, how do we know if an AI and ML is reliable? I mean, if we have a good functionality, you know, that's great, but if it's not reliable, then, you know, that creates its own problems.
Mm-hmm. Yeah, so I can speak from our perspective in cybersecurity, because, you know, general reliability is going to depend on more than just necessarily the confidentiality, integrity, and availability of the information. The overall operation of the AI system, the availability of other aspects of it that might not be cyber related, could impact reliability. You know, the air conditioning unit in the data center, right? That's not cybersecurity, but if that's not sufficient for the operations heat production, you know, servers may turn off, and that might reduce uptime. So reliability is a concept that goes beyond just cybersecurity, but cybersecurity does, of course, play a very key role in maintaining a reliable, maintaining uptime, keeping a system reliable in its connectivity and operation at the least, maintaining, you know, availability of data and the integrity of the data, which are two key components to something operating as you expect it to. You know, bad data might result in bad decisions, even with an AI model, and no data might result in another wrong decision, because no data might still result in a decision. It just might not be what you really wanted to do, which would be respond to a bunch of stuff. So, you know, disconnection of different components in a really complex IoT system can definitely have reliability impacts, that, especially if you zoom out to considering it, say, like a consumer product. The device in your home, right, it's going to operate as long as I have power. But if the back-end servers, there's an outage at the cloud level, I might lose functionality, reduce the reliability. Will it have a safety impact to tie it into the, you know, course of today? If it's the, you know, the product behind me that maybe you can see, probably not. If it's an oven or the HVAC system, or even the lighting of the house, that could arguably cause a safety concern, depending on how that product's being used. And I guess it really drills down maybe in kind of this kind of case, well, how it's intended to be used. If there's like a known hazard that can come from the use of this product, then yeah, 100%, cybersecurity is going to be paramount to, you know, at least understanding what, you know, those control states that Mark mentioned in his presentation, understanding how those can be impacted by lack of connectivity and your inability you know, if your control states shrink significantly, but the operational states of the product don't shrink significantly with lack of connectivity, then all the best planning in the world then voids that fundamental, you know, axiom that he put out there, just because now you don't have your cloud that tells you not to go do certain things at certain times of day. Now, there are, of course, I mean, this is maybe a facetious example, because there's, you know, are easy engineering ways around this. Maybe not easy in every instance, but I think we know how to build reliable systems with fault tolerances like these. But that's really the crux of cybersecurity, right? Like being able to identify that there is lack of connectivity, ensuring that all entities that are accessing data or accessing a channel of communication have authorization and are operating at appropriate privileges. These are the bits and pieces that build up. You know, you do these little things, maybe not little even, but you do all these things together in concert to then achieve a level of assurance of that data, a level of integrity of that data, availability of that data, and confidentiality of that data, to then build upon, as I was trying to hint at my presentation, you then build on that to say, and we've done these other things for reliability. And so we have the security there, the cybersecurity, to know that the connectivity is going to be preserved whenever possible, to know that we can handle lack of connectivity and outages. And also, we've done these other things that are important to reliability and important to safety and important to privacy. I don't want it to sound like cybersecurity is the end of it. There's more. And in all of these other, those other areas that branch out, right? And those considerations are just as important, and as I also highlighted, may conflict with some of your cybersecurity goals. So, yeah, word soup there a little bit, but that's, I guess, the back and forth of how I see the connection between reliability, cybersecurity, and even some of these other domains.
You bring up a really interesting point, because when it comes to security and safety, on the world stage, in a lot of places, those words are synonymous, even to the language. The word for security and the word for safety is the same word in their language. And as such, it seems, as you've talked today, that there's similar processes upon how you can test and evaluate safety, maybe in the same frameworks that you have for, say, security. Could you kind of speak a little bit more to that, please?
So the exact testing of it, I'm not quite the expert there, but I could speak to a little bit of where there are obvious connections, or not obvious maybe, but there are certainly connections between those fundamental levels. I was highlighting them a little bit at that high system level, these domains and how they're connected around reliabilities related to integrity and availability, right? So in that kind of way, you may be able to, and there are certainly going to be commonalities between methods of delivering cybersecurity and testing for cybersecurity and methods of delivering safety and testing for safety. That said, I could also imagine off the top of my head ways that that's different, or at least preferred solutions might be different in different circumstances. So one example of how these things are naturally related, right? Like digital access control. It inherits from physical access control, right? Like before we had computers and wanted people out of certain computing systems, we had rooms and buildings and we wanted people out of those places. So the concept of locks and safes, I think there are easy analogies in digital world, right? We have encryption, we have passwords. And in fact, we're even trying to backwards make the physical world more backwards compatible with the digital world. Keys are annoying because they don't work on my computer to get me into my email, even though they get me into my office. But my PIV can get me into both the physical door and into my email. Or a password, if that's programmed and all works together, right, can authenticate me in both places with the right hardware. Now, so that convergence naturally is going to mean that some of the testing is going to be duplicative, right? Like safety and security are becoming intertwined, right? If you can hack my password at the terminal of my door now, that's how you break into my office. That's how my security might be voided. And I might be put in maybe even physical danger, depending on what you're trying to get in the office to do. It might not be necessarily a theft, right? But in the digital sense, right? In the digital sense, the same kind of concepts, they're just commonly there isn't that safety component for an IT system. Breaking into the computer servers of a company, it's data exfiltration, it's reconnaissance, it's financial gain most likely. An IoT system, I think, really brings in that possibility that a digital vulnerability can introduce a safety issue. And that's another area, I think, where you could see in the testing a convergence between, and it's not, I wouldn't call them safety vulnerabilities, but there are vulnerabilities with safety implications. And that's going to lead to a meld of the digital and the physical in assessment, right? You have to look at those together. And I'm saying this at a high level. I don't know exactly what that looks like or how that's being done today in depth or all anything like that. But that's to me where I see these are coming from the same core concepts: security, cybersecurity, safety, and there are definitely going to be crossovers. But then, of course, there are going to be differences in how you approach these things.
Sure.
Yeah.
I'd like to talk a little more on the connectivity and the calibration of, say, these sensors. Kat, could you address some of that as it relates to, say, IoT for us?
All right. So again, NIST and especially our division, we don't focus on calibration of sensors. So I think, Nevin, that might be a question perhaps for someone else.
Sure.
We do focus on cybersecurity. That would not be kind of in our wheelhouse. So maybe you can, I don't know if there's someone else perhaps on the panel.
No, I was just thinking more of the standards for IoT. Right. No, I was thinking more maybe speak to some of the standards on IoTs, because, you know, as we have reliance on some of these capabilities in IoTs, and we need them to be dependable and reliable, there's obviously some concerns of left-right parameters as to, you know, what's the minimum performance level and ideal performance levels, and how do we ensure that they're performing to meet expectations?
Right. Well, we focus a lot on the area of cybersecurity. And there are a number of cybersecurity guidelines out there. I don't know if there are any studies out there that actually can draw the direct line between, I think, a lot of these concepts Mike was just talking on. How does cybersecurity draw a direct line to things like reliability? And yes. Will the device perform as expected? However, we work on the assumption that if a device is built with good cybersecurity and good cybersecurity practices, you can expect that it will be more reliable. So we do have a number of guidelines that we have applied and we have published in that area. I do have to say, and I'm sorry for joining a little bit late, when it comes to cybersecurity, one of the areas that we always struggle with is that we have 5 principles that kind of guide our work. And one of them is one size doesn't fit all, just because there's such a wide range of devices. So our guidelines are very high level. They are outcome based. We don't actually point to any specific standard because we say there are so many devices out there and types of devices. There are constrained devices in terms of processing power. They're constrained in terms of connectivity and whether they have continuous connectivity. They are constrained in terms of energy. And in order to provide the marketplace with the flexibility to pick the right approach to achieving those outcomes, what we do is we work kind of in the space of where we define the outcomes that we think are the desirable outcomes as a minimum. And we allow the marketplace to kind of evolve and identify standards. And in many cases, there are multiple standards. I wouldn't be able to point you to any single standard that we think is the one and only standard that fits all use cases. We also think a lot of it is risk-driven, and that kind of goes back to the balance of trustworthiness, the risk appetite, and what is your priority as an organization. If it's a device that's being used in a safety critical system, you may opt to say, hey, when it comes to secure updates, I would prefer that those are not applied automatically because I don't want those being applied in the middle of me using a perhaps a pacemaker and a device. I want that to happen only when it's in a doctor's office and when that can actually be done under a controlled situation. You know, so again, we don't have one single standard and we don't have one single piece of advice. We have a process we've articulated in 8259. We recommend manufacturers look to that process to identify the right security requirements, and we give them an initial set of what we call baseline outcomes that we say, these are a good starting point. But again, it's really for each manufacturer to understand best their use case and their priority.
Sure. No, that's a great point. As you spoke to on standards and consistencies, and Mike talked about, you know, obviously the inverse of that, the anomalies that sometimes present themselves in those anomaly detections. I'd like to ask you, sirs, maybe kind of, can you address some of those as they relate? Because there's a couple of things I'm really curious from your presentation. What really helped us think about a couple of things. One is the anomaly detection, and then the other is, in the old days, we would bring the data, you know, to the computer. We talk, you know, working in the sandbox, as we used to call it, and now we kind of do it the other way. We bring almost computational capability to the data, and that helps us with a lot of things. It allows us to, you know, have quicker results. It also helps us understand, you know, that what specifically is creating the problems that we're seeing, so we can attribute it and understand, you know, is AI, ML a contributing factor to that, and both reliability. And then there's a latency issue. So could you address first and foremost the anomaly detection and the implications of that specific to things like safety and consumer products?
Yes, absolutely. And yeah, Mike raised very interesting and good points. And actually, we do have a lot of customers in commercial space who are actively using machine learning and AI, basically just to detect anomalies or detect patterns, pattern recognition, right? Whenever you're getting sensors data, and if it's consistent, it means that sensors are working just fine. But if there's a spikes, kind of inappropriate behavior, for example, my smart home door lock is not opening when it's supposed to, right? That's a sign that something is going on with that particular sensor. And that could be tied back to the recall campaign, right? So if you see like a consistent behavior that that particular door lock is not working as it's supposed to, you can start a particular one. Or, I mean, from the safety perspective, right? You don't really want to be locked out of your house. And again, so all those AI and algorithms can help, right? Go through vast majority of data that you are collecting over a long period of time and see how this is supposed to be, right? Detect those patterns and apply those patterns on the data that's coming from the sensors in real time. That basically will tell you if there is something going on with this particular kind of aspect of the data that you're receiving or not. Going back to your kind of bringing horse to the water or water to the horse type of approach, obviously, right? Having data and the computation capabilities in one place would help a lot, right? So especially with the latency issues, whenever you're combing through data lake, for example, and the data lake is not a novel concept anymore. So a lot of data from the different sensors can just end up in a data lake. How are you going to process that? So there's a different approaches, load data in data warehouses, could be costly, could be not, right? So how are you going to apply all those machine learning algorithms? And that's where, particularly part of my presentation, all those kind of tools that aimed to help data scientists to create data catalogs, right? To properly classify data, and then to develop machine learning algorithms to build more smart AI capabilities. And going to Mark's point of view, right? That's how you're going to test if your AI doing what it's supposed to do, right? Applying the same patterns, and again, depending on like it's a deep learning or not deep learning kind of technologies, and you can see if outcome matches to your expectations. That's where the high performance computing comes into place, right? So that's where you need to run through the not a very big subset of data, creating a small subset of data, but you're running an algorithm and looking at an outcome. Is there a kind of pattern or not?
You know, you bring up an interesting point when it comes to the smart products. Most people think that all the computational capability happens within the product, not realizing the cognitive capability actually happens, you know, in a lot of respects in a cloud or in a sandbox somewhere else. And the device is performing more of a sensing and receiving an instructional capability. Could you speak more to that so people can see how those different pieces and parts and where the cognitive capacity of AI actually is applied? It's not, always in the device. Sometimes it's the device is just, a collection of sensors and a recipient of instructions.
Exactly. So, for example, I guess majority of people, they have like a Siri or Google Assistant on their phones. Whenever you're interacting with those chatbots, those assistants, all your requests actually going to the cloud. They're going through NLP, natural language processing recognition, extracting your key phrases, and then running algorithms trying to understand what are you actually saying, what are you asking for. Sometimes it could work nicely, sometimes not. It all depends what kind of algorithm. Is it like an AI behind all this? I mean, trying to find the relevant content, or it's just simple if-else kind of condition running, and you can see that very easily by the outcomes. And once again, so nothing happening on your phone, all data going to the cloud and coming back to your phone as a response. So you definitely would need to leverage more powerful compute capabilities in the cloud to achieve better results.
That's a great point. And a lot of times when we see AI, we're not sure if it's a function or a feature. Sometimes it is a function like natural language processing. Sometimes it's a feature to help, manage risk in that respect. Tracy, you talked about that in your talk on the micromobility. Parts of it were showing us the functionality of these devices, and other parts were showing us the features where it helped ensure that we were operating in a safe environment. But could you elaborate on that a little bit more? Because I find that very fascinating.
The difference between the functionalities and the features?
Yes, and how do you identify when AI is a function and when it's a feature, and how do you test and evaluate those? Because first and foremost, of course, we need to know that so that we can understand, is it contributing to a hazard that might have safety concerns?
Sure. So, I mean, I think that whether it's a feature or a function, it's a function, right? So each specific capability can be evaluated independently. Like a great example is geolocation. Here you've got a ground truth. You can compare what the actual location is to what the location is being provided by the device. Like Serge said, is it doing what it's supposed to do? And often with something that simple, it's easy to figure out like why the location isn't accurate. Is there not enough coverage? Do you have a faulty transponder, something like that? It does get a little bit more complex though when you're talking about more complex systems like machine vision or computer vision. And that's going to involve more complex algorithms, and sometimes those algorithms aren't transparent. So even the developers don't necessarily know why it's giving the outputs that it's giving. So in that case, when the machine gives you an output that's incorrect, like mistaking a person for a tree, it can be a lot harder to diagnose the why of the matter. So, I think it depends on the complexity of the feature, how to test it, and what you're going to get.
Yeah, it's a great point. And a lot of times you'll have an AI functionality or capability within systems. It's used for a multitude of different reasons.
Yeah.
As you were saying, can you park it here? Is it a safe way to park? Is it safe to ride? Referencing your talk on micromobility. So as you look at that, I mean, how do you isolate those pieces and parts as you're looking at, a potential hazard to determine, the contributing factor of each, not just the AI capability, but the multitude of applications of that capability within a system or within a product? As you mentioned, it's rather complex.
I'm not a T&E, I'm not a test and evaluation engineer, but I think that you have to do it systematically. You have to say with each function, where does it live in the process, and then test it in each process. And that may mean that you are testing, someone mentioned testing things over and over again, I think it was Mike. That may mean that you're testing geolocation 5 times but it's still necessary.
That's a really great point. And with that, I am going to jump it over to Travis, because this is the world that he lives in. Travis, as you talked about all these different aspects, how I think we would all agree that AI is really complex, and when you break it down, it becomes pretty simple, but it fits together in a system in interesting, unique ways. How do you isolate and analyze each of these capabilities? Let's say we had a product that had some hazards in it that were creating an unacceptable risk in an unsafe condition. How do we determine if they're the contributing factors of each of the pieces and parts? Or, are they not sufficiently managing risk, or are they contributing to the hazard? How do you isolate and analyze these so you can discern if AI and ML is if it's a contributing factor, and if so, how much of a contribution is it making to the hazard?
I think in some cases you can't. I think Tracy was talking about the fact that even the developers don't know why it failed. I think that's one of the challenges with this is that, a lot of the clients that we've been talking to will talk about they develop an algorithm through an evolutionary process where they create, a number of, let's say, bot algorithms that are given a task. And whatever one does the best goes to the next generation, and they clone variations, that goes to the next generation and the next generation. By the time you've gone through a couple thousand of those generations or even more, even the programmers have no idea why the algorithm works. It just does. And that's one of the really amazing things about AI, but it also, to your point about how do you isolate and address what's the problem and how do we fix it, it may not be immediately addressable. I think that's one of the challenges about having something unlocked and out there, and even the upstream evolutionary processes where essentially the evolutionary process is doing the programming, not a human being. You're creating a number of scenarios that give rise to an algorithm that does something. I think that, Mark talked about AI and monitoring AI, and that may be the only way to get back to both of those problems. The problem being which variable contributed the problem, right, from the evolutionary process, or no, this is an AI that's learning in the wild and it needs to be monitored, to the point that was made earlier about from Serge, was the real-time pattern recognition monitoring that can only be done probably by an AI. So it's this kind of weird, snake biting its own tail phenomenon that in some cases the problems with AI may require AI to solve them, whether it is which part of that algorithm is the flaw that caused the problem, whether that pattern recognition in the field is going aberrant and needs to be corrected, and so forth. Because I think it's even now today in 2022, in a lot of these cases, it's already gone beyond just a programmer being able to pull up the code and go, oh, I fixed the line and it's correct.
Yeah, it's interesting you brought up the point of life cycle. Deb, you mentioned that in your presentation, as we talk about the design, how is architecture, the development, the quality of pieces and parts that are used in its creation, and the deployment, the environment in which it lives. And you talked about these understanding what's the expected operation towards its intended use and unforeseen use. Would you mind elaborating maybe more specifically on that, and maybe if you had some examples to help us better understand, because that was a great conversation that you covered a lot of ground. And as we've talked about here, I don't know that we all know exactly how it's going to perform, outside of the development cycle and in the environment. And as Travis just mentioned, it evolves, right? The machine learning attributes allow it to iterate on itself and self-evolve, unlike any other product prior to. Could you maybe speak a little bit more to, the aspects of its life cycle and how do we know what to expect and know when it's outside of its expected range?
I can try. All right. So
oh, you do great. I know you will.
It's a challenge for sure, right? I don't think that, and again, this is going to be my personal opinion. This is, I don't think the way that like I said, I don't think the way we look at products now as in off the production line, right? That's when they're done, and you might do a follow-up to make sure they're still manufacturing the same way, right? With AI, you're not going to be able to do that. I think that but I don't know. I mean, you're going to have a safety culture within the organization that makes the product, and they're going to have a regular cadence, I believe, on validating that AI. Is it still repeatable? I think you have to go through those risk assessments at multiple times, and maybe it becomes a whole different kind of scheme. And again, I'm just thinking outside of what's happening today, but even with cybersecurity, a bunch of these other areas, if you're looking at conformity, those conformities are real short. They're like year. They're not your typical long, because they know that the product isn't the same or the risks are not the same. I think also that piece that I said about sharing your known issues, your known pitfalls, the known threats, and learning from that, because some people are buying these training sets. They're not developing the training sets, right? They're getting them from a different thing, and there are some risk in those. So again, big challenge. Don't know that I gave you a good answer, Nevin, but I just know that it is going to be an evolution that we're going to have to consider more and more.
I think we hear a prevailing theme here, and that's this is challenging. This isn't easy. Hasn't been done. And again, the reality here is it's incredibly complex. And the question is, how do you break down the complexities into a structure, right? That you understand what those dependencies look like. And then, in case it wasn't hard enough already, it continues to evolve because of its machine learning attributes and iterates. So Travis, I would really be curious, because at the latter part of your presentation today, you talked about these iterations. I'd be curious, how can we establish through a means to monitor and measure those iterations to understand the influence and effect they have on a product as it evolves?
Well, I think Kat said that each supplier needs to really understand their product well. I think the idea of pattern recognition that Serge was talking about, and monitoring real time what's going on is a key aspect of just getting the alert, right? Knowing that there's something happening. I think even some of what Mark was talking about, where some of the information in social media, people indicating things aren't working or they've been injured or stuff, could potentially raise red flags. So, to what Deborah was saying a minute ago about having a safety culture in the organization, I think all of the other speakers were talking to that to some extent, whether we're talking about AI monitoring that, or listening to customers, or just proactively assessing it. So I think that's the first thing, is to have that assessment, to know that something's gone wrong. Then, the challenge of not knowing exactly what the problem was in terms of how to fix it because of the evolutionary challenges is going to require a different mindset with respect to, you can't just update the software and push it out like you might with a traditional connected product. So it's gonna require some very rapid, again, maybe some evolution on an alteration or a version of that algorithm, which is then tested and then released, or a mitigation that's put out. Even without knowing what caused it or exactly how to fix it, there may still be solutions available to mitigate risk, alert consumers, notify people of hazards, and things that are still available to manufacturers even using these types of devices.
And thank you for that answer, and all the presenters and panelists today for their answers. It really shows how, we brought all the pieces and parts of what everybody brought to the table today, and helped paint a very comprehensive and complete picture. Thanks to all of our panelists and participating for joining us today, and for the contribution to this important consideration on consumer safety. Today's forum outlined the complexities of AI and ML in regards to test and evaluation, and provided a multitude of perspectives and operational framework to monitor and measure the implications and impact of these amazing technologies. It addressed how to qualify the test components and their implications and the resulting impact to consumer products. Unique and interesting insights were provided, which afforded us to examine how to evaluate these technologies as we looked at the operational implications and impact of AI and ML. Finally, it provided an example of how these innovative capabilities interact and evolve over time. All in all, the presentations were phenomenal, and the subject matter experts provided exceptional insights to the world of applied AI and ML, with focus on how to test and evaluate these transformational technologies. Before we close, I want to remind everyone that CPSC will be publishing a meeting log on our website that will include a brief synopsis of the day. As we have stated, this forum and the agency's efforts to develop a framework are in the very initial stages of an overall effort. We look forward to ongoing dialogue and encourage you to reach out to us if you want to share any further information that you believe will help CPSC ensure safe products for the American consumer. Thank you all for joining us today, and a special thanks to our speakers and for all who contributed to an informative forum. I would be remiss if I didn't thank those within CPSC who worked so very hard to put this exceptional forum together. The CPSC AI and ML work group, your moderators, Einstein, Simon, and Joanna, and our technical team, Dan and Cynthia. And for the vision and advocacy of our leadership team, Dwayne Boniface, Joe Rech, and the commissioners, especially our chairman, Hon Sarek, who graciously took time from his busy schedule to join us today. All the best to each and every one of you, and I hope you have a great and safe day. Thank you.